Welcome, everybody. Good day, good afternoon, or good evening, everyone. My name is Ermias Kebreab. I'm the director of World Food Center and Associate Dean of Global Engagement and Professor of Animal Science. Today, in partnership with UC Davis Clear Center, we are presenting an independent dialogue as a precursor to the UN's Food Systems Summit in September of this year. And today's dialogue is called Roadmap to Climate Neutrality in Beef and Dairy Sectors. Thank you to our panelists, facilitators, and invited experts for being with us. And thanks also to those of you watching the recording of this dialogue. The format of today's event is as follows. We will give an overview of the topic, then introduce the panelists, and each panelist will give a brief presentation. And after the presentations, everyone will enter their assigned breakout rooms and will participate in a facilitated dialogue. Then we will all regroup, and the breakout room facilitators will give a brief summary of what was discussed and the consensus of their room. Before we begin, there are a few housekeeping items I'd like to cover. Invited guest microphones are muted right now. We will unmute you after the presentations end. And please turn off your video for the first part of the event. And please hold your questions until the discussion period and use the raise hand feature in your toolbar to be addressed. If you have any issues, send a chat to the host and you will get targeted help. The video portion will be available in a few weeks on World Food Center website. Now I'd like to introduce my fellow convener of today's dialogue, Dr. Frank Mitloehner. Dr. Frank Mitloehner is a professor and air quality specialist in cooperative extension in the Department of Animal Science at UC Davis. As such, he shares his knowledge and research both domestically and abroad with students, scientists, farmers, and ranchers, policymakers, and public at large. Frank is also the director of the Clear Center, which brings clarity to the intersection of animal agriculture and the environment, helping our global community understand the environmental and human health impacts of livestock so we can make informed decisions about the foods we eat and while reducing environmental impacts. Now I'll turn it over to Frank.
Thank you, Ermias, and good morning, good afternoon, good evening, everybody. I'm happy to present today's featured panelists. I will now read the three bios for our panelists, starting with Dr. Jason Clay, who is the Senior Vice President of Markets and Executive Director of Markets Institute at the World Wildlife Fund. Jason is an entrepreneur and thought leader within the global food sector. For the past 25 years, he has identified the most significant threats to biodiversity and habitat. He developed strategies with the World Wildlife Fund to work with others to help reduce the impact of agriculture, livestock, and aquaculture by working with companies to understand and address how they can use their supply chains to maintain the natural world we all depend on. Our second speaker will be Dr. Sarah Place, who is the Chief Sustainability Officer at Elanco, where she provides technical expertise on sustainability issues to customers and supports Elanco's health purpose. Prior to Elanco, she was the Senior Director for Sustainability Beef Production Research at the National Cattlemen Beef Association and an Assistant Professor in Sustainable Beef Cattle Systems at Oklahoma State University. She received her PhD in animal biology from the University of California, Davis, a BS in animal science from Cornell University, and an AAS in agricultural business from Morrisville State College. Our third panelist is Dr. Karen Boucherman, who is a senior research scientist at Agriculture and Agri-Food Canada's Lethbridge Research and Development Center with more than 30 years of experience. She is recognized as an international authority on greenhouse gas emissions from livestock farming. Dr. Boucherman served on the National Academy of Sciences Nutrient Requirements for Beef Cattle Committee, and she has published more than 500 refereed scientific publications. With that, I want to turn over the word to our first panelist, Dr. Jason Clay. Jason, the floor is yours.
So good morning, and thanks for hosting this session. First, a little bit of background. I wanted to explain a little bit about why an organization like World Wildlife Fund is actually on this panel today. And the point is that WF actually cares about the production of food production of food because it has had the largest impact on habitat and biodiversity of any human activity over several millennia. Our goal is to make people aware of the impacts of producing the food they eat, but also to help them ensure that whatever they eat is produced more sustainably. This is important for beef and dairy, and also the feed that is used to feed them. This presentation outlines a U.S. dairy strategy to produce net zero milk, and I think it's important because we can all learn from how individual producers and whole sectors are beginning to address this issue. Our goal is to help document this journey, to help others learn about what works, but also what doesn't. The goal is to flatten the learning curves, because with climate change, we're all going to have to learn a lot faster than we have today. So let me talk a little bit about the U.S. dairy net zero pilots. There are going to be 3 to 5 pilots in different geographies around the country. The average is about 3,000 milking cows and nearly 500 dry cows. Some 5.7 thousand acres are going to be used for each of these operations, and they'll produce about 1 million hundredweights of milk per herd per year. The focus is on the environmental impacts and kind of closing the economic gap, or finding the economic incentives to make these reductions work. There is focus on the feed print of the operation, the enteric print of the operation, the energy use and print, and the manure. The feed, enteric, and manure impacts are the largest and are the ones that a lot of the emphasis is going to focus on, but no single strategy is being used. They're using about 15 or 16 different strategies that are named, and a number of others. So there is no silver bullet here. The idea is to look at what the baseline for dairy of this type of operation is, and that's where in the column you can see the largest sources of greenhouse gas emissions in pounds per gallon, coming from cow care and efficiency, the enteric print, the manure handling, the feed production, and the renewable energy. This is just a schematic showing where the major impacts are, with the enteric emissions being highest, the manure next, and the feed third, or it depends on your feed sources as to how that works out, with energy being a little bit less. As I mentioned, there's a lot of different strategies being pursued to reduce, to make it more sustainable and produce less greenhouse gas emissions with 1,000 cuts, I think is the way to think about it. The enteric has the largest, in this particular model, the largest source of emissions, followed by manure, and then feed, with renewable energy or energy on farm much lower. But the enteric footprint and the manure handling and the renewable energy are still going to have impacts, even with the strategies being pursued in this model. And where the greenhouse gas emissions savings come from are the reduction of greenhouse gases in those areas, but actually having positive greenhouse gas impacts through the feed work, through greenhouse gas benefits from renewable natural gas from manure and substrates, and then selling substrates like liquid ammonia, NP and K, into markets that for greenhouse gas positive inputs, as in this bottom line, community substrates. The economic impacts are calculated per hundredweight and then per total strategy. And what we find is that most of the income coming from these changes are coming from manure management first, dairy farm innovation second, and energy generation and use third. And that comes to, with this particular model, with this number of cows, about 1.9 million dollars per year. Happy to send anybody a copy of the case study or a link to it if you're interested. So what we're seeing is that there are a number of current strategies, and for some producers, actually new strategies around manure management and biogas digesters, also around feed supplements to reduce enteric emissions, around feed from regenerative ag versus from conventional ag production, using practices that reduce greenhouse gas emissions from input use, et cetera. And then tapping into California's low carbon fuel standard and US government programs and grants from the EPA and USDA. I think the future strategies that are going to be helpful for the industry are long-term contracts that are linked to, long-term contracts that are linked to energy, to greenhouse gas emissions reductions, and to carbon insets, organic fertilizers that can be sold at a premium, the liquid ammonia and NP and K. Now there is an issue coming up that this may be defined as not organic fertilizer if it comes out of a biogas digester from a conventional dairy. And that would be a huge impact on the ability of farmers to get to net zero dairy, because this is one of the key ways that they're going to pay for it. An issue I think also that's going to become important, this is a very large scale dairy operation. We think a lot can be learned from this type of operation. Some of it can be adapted for smaller farmers. Some of the technology can be as well, but we're going to have to do more to work with small farmers to aggregate maybe some of the production, maybe manure, maybe other ways to think about bringing them into these kinds of systems. And then we're going to need feed supplements for enteric fermentation issues for grass-fed operations. And that would then cross over for beef too, if we could actually find ways to make that work. We're talking with a number of companies about other environmental management fees to create a kind of bundle of services and strategies for more resilient production that they could support, in addition to reduced avoided or sequestered carbon. Also things like water quality and stream flow throughout the year, habitat, biodiversity, et cetera. We think it would be a mistake to put all of this just on carbon emissions reductions, or especially on soil carbon. We don't think that the science is quite there yet. We're not sure about the permanence or about the durability, especially during periods of drought. And then there is a role for public and private partnerships, bringing in rural areas waste from cities and towns into the biogas digesters could create a whole other different level of production of materials, and especially nutrient cycling, which is going to be the most valuable thing that comes out of this. So there's no silver bullet here. It's going to require multiple strategies to reduce greenhouse gas emissions from milk to accommodate different geographies and scales of production, not just in the US, but everywhere. And most emissions today are actually coming from the poorer performing producers, not the better ones. And global averages shape dairy's reputation and are heavily influenced by companies like India. So at the very least, I would say there's a problem with averages. We don't solve problems by averages. We solve problems by understanding where the key impacts are and what the incentives are to reduce them. And we need to dig into each of these situations to figure it out. But simply improving North America and Europe in the global context is not going to solve the dairy problem. We've got to deal with other producers. Even in the US, the strategies are going to need to be adapted for small scale dairy realities, and incentives are going to be needed to stimulate change. One other issue that's come up is that while finance is critical, if producers have to sell carbon credits to cover their changes and the investments they need to make, then they no longer own that carbon, and they can no longer claim that their milk is carbon free. And so we've got to address issues like that by maybe trying to include these kinds of payments as environmental management fees from downstream buyers of milk, so that it becomes part of a resilient milk production system. And that, I think, there could be some real traction for. Governments with subsidies and other programs, and buyers with long-term contracts, and using reinforcing purchases like energy. If you buy a lot of milk, have you thought about actually buying energy from biogas digesters or carbon credits from that energy as a company? These are things that need to be floated more systematically to large retailers and brands that are buying milk. Anyway, most of these programs are not yet in place, and so they're being developed now, they're being talked about now. We need to start doing this much more quickly. Thank you.
Thank you very much, Dr. Clay. The study that he discussed, the case study, is also linked in the chat. Next up is Dr. Sarah Place. Sarah, the floor is yours.
Thank you. Thanks for having me. Good morning, good afternoon, good evening, everyone. So I'll provide a bit of a high-level overview here and really build upon the great work that was just shared by Jason Clay. And just to ground ourselves, of course, we're talking about sustainability, and this is such a complex topic. We're really zooming in on the environment and on climate today, but I think it's always good to remind ourselves that sustainability is a cross-cutting issue across multiple domains. The environment is absolutely key, and there are many different facets of that, as was just referenced with regard to water quality, air quality, ecosystem services that are all incredibly important. But we also have to think about the economics, both the affordability of food and producer economic viability, which I think is absolutely key and what was just touched upon, and those social issues, right? Everything from animal use to nutritional quality. So I just put this up here as a reminder that as we go through this, sometimes there are those positive synergies where we can have win-wins across domains, and sometimes we get situations where we can have trade-offs, real trade-offs. And so we just need to recognize that sometimes we can't have our cake and eat it too. And I think that's where we get into some of these discussions later today about policy and other incentives to try to overcome some of those trade-offs. But just to ground ourselves, when we think about emissions from a global perspective, and I think the comments about averages and the hazards of those that was just made is really important, but it's also good to just ground ourselves in what is the global picture for cattle, right? As we talk about cattle and trying to achieve climate neutrality. So right now, if we look at the latest data available from the UNFAO, we'd say beef is around 6% of global emissions and dairy around 3%, and that's inclusive of all facets of the life cycle of production. And these pie charts that are over to the right-hand side of the slide are just showing us where those emissions are coming from. And these profiles of emissions will definitely change depending on where we are in the world, right? If we look at this globally, we'll see land use change being a very important component of the emission profile of beef, of cattle meat. If we were to go to some place like the United States, it would play a much more minor role or non-existent role. And we're more concerned about the loss of pasture, actually, rather than the pasture expansion and the loss of rangelands. But main takeaway here is that even at the global level, what really dominates is enteric methane for both species and methane emissions in general, right? And it's important as we talk about how we're going to achieve a climate neutral cattle production system. The other thing, digging a little deeper into this question of why averages and why we need to think about this differently depending on where we are in the world is important, is looking at the trends over time, even with just cattle stocks, right? So what I have on the slide here is global cattle stocks just from 1961 to 2019. This is just data from UNFAO stat. And we're looking at essentially developed versus non-developed countries. And we see a different story there, right? So really across the board in our developed countries, we've seen a decline in cattle or a stable cattle herd, whether we're talking about non-dairy, of course, beef, but other purposes, draft, for example, in developing countries, and dairy cattle. In developing countries, we've seen herd expansion, right? So this is important as we have these discussions about climate neutrality, about reducing greenhouse gas emissions, is the picture can look different depending on where we are. And the reality, again, back to those services that are being provided by the cattle industry, obviously expansion is happening in certain locations to meet increased demand, right? And so we have to balance all those different facets when we're talking about this as we go forward. On the positive side of things, we have seen across the board from a global perspective, the emission intensity or the direct greenhouse gas emissions that come from beef and milk production decline over time. So that's what's on the right-hand side of the screen, that panel. So we can again see from 1961 to 2017, a decline in both. However, we also need to think about absolute emissions, right? And so that's what's on the right-hand side. So we've seen some decoupling, right, of production from emissions per unit of production, but that decoupling has not been enough to essentially freeze the absolute footprint or the absolute amount of direct greenhouse gas emissions, meaning emissions coming from manure and emissions coming from the animals themselves over time, right? So that's a key thing that we got to think about, right? Ultimately, the atmosphere doesn't care about per se emissions per unit of milk or per unit of beef. It cares about the total amount of emissions. That's what's going to matter in terms of affecting climate. So we always had to keep those things in mind. That said, the reference I made earlier to methane, I think really what's a key opportunity here, and I know Dr. Mitloehner and others have really been working on this, is saying, hey, we have a huge opportunity here with methane if we're able to reduce methane and get essentially a climate impact quicker. And that's really just due to that short life cycle of methane in the atmosphere, right? So not anything new to any of the attendees here today, right? If we think about the biogenic carbon cycle, ultimately what cattle are doing or the methanogens within their stomachs are doing is temporarily transforming biogenic carbon to a higher potency gas. And so in the framework of addressing climate change and trying to keep our temperatures within 1.5 or 2 degrees Celsius compared to pre-industrial times, we really had to think about that total amount of emissions that are coming from the industry, and can we hold methane either steady or decrease methane and essentially contribute to, hopefully, the reductions of methane emissions within the atmosphere, right? Which is the ultimate goal here. But just knowing that, I think this is important as we talk about this, is recognizing the trade-offs here. If we use a CO2 equivalent basis versus a CO2 warming equivalent basis, I think it just needs to be said that, as was shown in that budget, the carbon budget prior for a dairy, it's very hard to achieve net zero CO2 equivalent emissions, just because ruminants are ruminants, and even with emissions reductions, they will still have residual emissions, if you will, that will need to be offset within the system. And that's a very difficult thing to do across an entire country or across the whole global cattle sector. So another way to think about this is using different metrics such as CO2 warming equivalents if our goal is truly around temperature change, which is of course what the Paris Climate Accord is all about. So I know this slide's a little busy, but this is just to highlight why I think this is really important in terms of how we frame this discussion. So what we're looking at on the slide on the y-axis is million metric tons of CO2 warming equivalents. And this is just a case study scenario of US beef production, okay? So the emissions from 2010 to 2019 essentially are the real emissions from the US EPA inventory, with an estimate there of all the other life cycle emissions that don't get counted for in the EPA inventory. So that would include everything from feed production, right, in terms of emissions from nitrous oxide from soils to all the tractors, trucks, everything else in the system. Hopefully that makes sense. And what we're looking at is going forward, what would it take to achieve a zero CO2 warming equivalent future for the US beef cattle industry? And so these different things that are called out on the slide here are just one example of what would be required in terms of emissions reductions to get to this future that by 2050, we actually can take this to a negative CO2 warming equivalence future, which is what we need to get to, right? And hopefully the sooner the better in this situation to keep the sector not contributing to additional warming. So I've just really called out, the overall reduction would be a 23% reduction in enteric methane for the whole industry, right? So this is back to the absolute reductions requirements by 2050 relative to 2020, which is actually quite a steep reduction. And this was brought up earlier, right, with the grazing dairies. And I think is what's one of those key innovations we need is, if we look at the US beef industry specifically, 85% of the total methane emissions are actually coming from grazing cattle, from extensive cattle. And so we need solutions to reduce methane, but we also need solutions that can be delivered to those animals in a cost-effective manner or a way that can be tracked and incentivized. So again, I just put this up here as a different pathway, a different view of how we achieve some of these climate reductions. I think what's important though is regardless if we define net zero as net zero CO2 emissions or net zero CO2 warming equivalent emissions, we need to reduce absolute emissions from the cattle industry. And that's something that actually hasn't necessarily been done in the last few decades. So regardless, we need an acceleration and innovation in a new direction. So I'll just wrap up by saying again, sustainability itself, very complex. I think we need to put this climate discussion within a broader context of all the other aspects of a sustainable food system that are important to us. I didn't touch on it too much, but I also think it's important to not fall into the false dichotomy of, plant versus animal ag. Rather, it's how they work together. And I think the concept of nutrient cycling and the circularity within animal agriculture needs to be re-emphasized. We need to strengthen those loops of nutrients where we can. And ultimately, I think livestock played a really important role with regard to food security, with regard to human flourishing in general. And of course, I work for Elanco, an animal health company. I think that's also the key thing, is to highlight there are win-wins when it comes to animal health and welfare, where we can improve those outcomes for animals and improve their productivity and therefore reduce environmental impacts as well, right? In addition to that just being the right thing to do. So with that, thank you very much for your attention, and happy to turn it over to the next presenter.
Thank you very much, Sarah. Our final presentation is from Dr. Karen Bushman. Karen, the floor is yours.
Good morning, good afternoon, good evening. Thank you very much for the invitation to be part of this meeting this morning. It's very interesting to see how this is all coming together. I've been asked to talk a little bit about enteric methane emissions and potential for mitigation and how that might help achieve climate neutral beef and dairy. So I just wanted to begin by saying I'm a research scientist, and my colleagues and I have been conducting research related to methane mitigation for beef and dairy since the late 1990s. And it's interesting, back in the 90s, when I first started down this lane of this scope of research, I couldn't get a lot of interest from industry, from consumers, from anybody. Even the government was looking at me, why are you working in this area? Fast forward 30 years, it's really interesting to see how the focus of the industry has really embraced the concept of sustainability in addition to production efficiency. So in our research, we use an array of techniques that range from screening compounds at the lab bench to look at developing potential feed additives, to conducting animal metabolism studies to understand what's going on in the rumen and the animal physiology, all the way to on-farm studies where we're actually documenting measured reductions in methane. So today, I'm not going to speak at all about our research in particular, but I just want to share with you my personal perspective on what I think is possible in terms of methane mitigation, where we are and where we could be in the future. So I just wanted to start with the question at hand. Can the US beef and dairy sector be made climate neutral, and what is the role in enteric methane? So I just started by putting this pie chart on the screen. This is data based on a life cycle assessment that was published some years ago by Thomas et al. Now, these actual percentages in the pie chart are going to vary depending on the production system, but this is just a general concept for the US dairy industry. What I wanted to show was from cradle to retail and consumer use for the US dairy industry, enteric methane emissions are about a quarter of the emissions. And if we just look at the farm emissions, then we're looking at maybe 35% of the farm gate emissions. So it's going to have a standard deviation, but roughly 1/3 to 40% of the emissions at the farm gate are enteric methane. So reducing enteric methane can have a fairly substantial impact on the total carbon footprint of milk production. But the point I want to make is that it's only part of the solution. If we were to reduce enteric methane by 50%, you can see in this chart, we would reduce the total CO2 emissions per kilogram of milk by about 13% across the supply chain and maybe 17, 20% at the farm gate. So yes, reducing enteric methane is going to be critical, but it in itself is not going to be enough to reach carbon neutrality. And I'm really happy to see Jason and Sarah's presentation that also made that point. Beef production is an interesting challenge. This is a life cycle assessment to the farm gate that we conducted for beef production in Canada. Beef production in Canada is very similar to beef production in the US. What I wanted to demonstrate here was the contribution of enteric methane is larger than for dairy. Now, here we don't consider land use change, but enteric methane is a large part of the life cycle assessment to the farm gate. But the challenge here is when we look at the entire production system, most of that enteric methane is actually coming from the beef cow herds. So yes, we can add feed additives at the feedlot, but using feed additives is very challenging for beef cow herds. So we have a challenge of high enteric methane emissions because animals are grazing. So how do you tackle that issue of grazing animals? We have the use of high forage diets. We often are feeding byproducts and low quality feeds, but we actually don't want to change that because that is the unique niche of beef cattle. So they're not competing with human edible food, but as a consequence, we have high emissions. And we also have those beef cattle grazing pastures that are maintaining those pastures that have sequestered or stored carbon. And so we don't want to switch the production cycle to feeding a lot of grain because we recognize the value of that pasture system. So beef cattle are really going to be a challenge for reducing enteric methane emissions. The next point I want to make is when we talk about reducing enteric methane emissions, we have to think about what is it that we want to focus on. We have two things here. We have a carbon footprint, and then we have absolute emissions. So when we look at a carbon footprint, what we're talking about is methane per kilogram of output, milk or meat. And that allows the industry to continue to grow. It can expand to meet the need for human food. But at the same time, if the industry expands at a faster rate than the carbon footprint decreases, we have an increase in absolute emissions. And I think Sarah mentioned that in her presentation. So we need to focus on carbon footprint, but we also need to focus on reducing methanogenesis. Now, I want to just briefly make a point about carbon footprint because that is very important, especially in the beef industry where we don't have that many options. So decreasing carbon footprint means that we're looking at reducing methane per kilogram of meat or milk. So we're really focusing on output, and that dilutes the feed energy associated with feeding the animals or feeding the herd. So ultimately that reduces that carbon footprint. And I just show an example of a study that we did. This is for the Canadian beef industry, and we looked over a 30-year period. Now, there's lots of published studies very similar to this, but this helps me make a point here. So over that 30-year period between 1981 and 2011, we looked at the greenhouse gas emissions per kilogram of beef, and we saw that over the 30-year period, there was a 14.5% reduction in greenhouse gas emissions per kilogram of beef. So about a 0.5% reduction per year. And that was due to better genetics of the animals, improved nutrition, better health, better feed production, all those management factors that came into play where the production system was adopting new technology. So yes, improving production efficiency is going to be very important, but it's only part of the analysis because as the beef industry expanded over that same time period, absolute emissions actually went up. And that's a story that we don't actually, the beef industry doesn't always want to share. We are more efficient today than we were 30 years ago, but emissions may also be higher. So the point then is that increased animal production and improved efficiency is very important. I don't want to downplay that, but it is not enough to reach the goal of climate neutrality. So we really need to look for direct ways of inhibiting rumen methanogenesis to reduce absolute emissions. So what are the interventions possible? Can those interventions get those large reductions in enteric methane that we need? What's the consequences for the animal if you reduce enteric methane emissions? What happens to animal performance? And what about cost for that? So those are all questions that the research community has really been focusing on. And with my little short 10 minutes, I certainly can't go into a lot of detail. But I did want to give you just a brief perspective on where things are at. So right now, I would say we have identified, and this is the global eye, the research community has identified two main ways of substantially reducing enteric methane emissions. We have the chemical inhibitor 3-nitroxypropanol or 3-NOP. On average, it looks like in most studies, we have about an average of 30% reduction, so not quite the 50 that we need. But there are reductions of 20 to 80% depending upon the dose and the diet, etc. The other technology is Asparagus Taxiformis, which is a red tropical seaweed, where we're seeing very substantial reductions in methane emissions. However, it's very early days because there's fairly limited publications. But the point is neither of those compounds is available for producers today. So this is still future. Just a brief overview of 3-NOP. I think this is really exciting. It's a feed additive, but it needs to be added to a total mixed diet in its current form. So once again, it's not something that's going to be easily adopted by grazing producers that are using grazing strategies. It's manufactured by DSM Nutritional Products. And 3-NOP inhibits methanogenesis in the rumen. So there's a number of studies now published in the refereed scientific literature. And on average, the reduction in methane, absolute reduction in methane, is about 30%. And as I mentioned, there is a standard deviation associated with that reduction. And in general, what we are seeing is no production responses in most studies. In most dairy studies. In beef, I think the jury is still out. There are a number of studies now that have shown potentially improved feed conversion efficiency in beef cattle production, but that needs to be confirmed in further work. The studies to date would indicate low safety risk for that product, and consequently, it is undergoing regulatory approval in various countries, including the US and Canada. In the EU, because of the way the regulatory authorities have changed the rules, there's now a category for environmental feed additives. The company I know is expecting approval for that product very soon. The approvals may take longer in North America. And the big thing here is we don't know the retail cost. I just wanted to mention that we've done a lot of work with this product. We just finished a 2-year study where we are measuring methane emissions at the farm level. This is a commercial feedlot where we are measuring methane and looking at how that feed additive could be incorporated into conventional diets, in backgrounding, corn finishing, barley finishing diets. And we're seeing essentially at the commercial level, very much what we're seeing at the research level, reductions in methane and small improvements in gain to feed ratio. Asparagus Taxiformis, as I mentioned, it's a red tropical seaweed, so it's not native to North America, but it can be grown up in tanks and dried and extracted. Here, the active component is bromoform. Bromoform is a halogen like chloroform, for example. For me, I'm not sure what the future holds for Asparagus because bromoform is a potentially safety risk. In the US, for example, it's classified as a group B2 probable human carcinogen. So it's going to be very important to assure that there's no residues of bromoform detected in meat and milk if we're using that as a feed additive. So far, it looks like there are minimal residues in meat and milk, although there is a more recent study that does show in some samples some bromoform. So I think this is a more upstream feed additive that there's still a lot of work that needs to be done in terms of safety, and also the greenhouse gases associated with just producing, harvesting, drying, shipping. That's going to offset some of the methane reduction. And it's going to be very difficult and expensive to produce it, although there is a lot of enthusiasm in the industry for this product. So time will tell. So here, I just want to give a very brief overview of some of the other strategies that are available now. I talked about the upstream strategies, but right now, improved animal management, as I mentioned, is very important for reducing the footprint. Breeding for improved feed efficiency. If animals consume less feed, that has a domino effect in terms of less feed having to be grown or shipped. So that's very important. Health, nutrition, fertility of animals. All those factors reduce intensity of methane production. Feed and management, lipids, we've identified feeding lipids at 2 to 4% of the diet can reduce methane emissions. Very effective. However, I wonder about the potential for adoption, because in a lot of cases, we're already feeding lipids in diets where it makes sense, and lipids can be costly. Forages, there's a lot of work that can be done here, improving digestibility, incorporating legumes over grasses, the use of tannin-containing forages, high starch forages, replacing grasses, high sugar grasses. And for beef cattle in particular, for grazing, we need a lot of work on to incorporate better pasture management and species composition. We know that species composition is very important for influencing enteric methane emissions. In terms of rumen manipulation, we have ionophores, which have a small effect in reducing enteric methane, but once again, ionophores are already adopted, so I don't see that as having a lot of future potential. There's interest in nitrate. We've done a lot of work on nitrate. It's electron acceptor, so it competes with methane formation in the rumen. This is very effective. However, there's some real problems here at the farm level because of the potential for toxicity and the safety risks. So I don't see that really going too far. Essential oils, I put these in bold because I think this is a really emerging strategy. There's a lot of products now out on the market claiming reductions in enteric methane, and there's some possibilities to further the work in essential oils. So I see that as something that's got some potential and needs some animal verification. And finally, tannin extracts. I think this is overlooked. We know that tannin-containing forages can be effective. However, there's limited tannin-containing forages in some geographical areas. We can extract the tannins from tannin-containing plants, for example, and feed those as feed additives, and they also impact nitrogen use efficiency. So in the future, I talked about Asparagopsis, 3-NOP. There's work on vaccines. There's some really exciting work on early life programming, and that means handling the calf in early life. For example, dosing the calf with 3-NOP and looking at long-term effects on reducing enteric methane emissions. Animal breeding for low methane emissions. In New Zealand, for example, they're already doing that for sheep. Challenging again for beef production because it's very hard to get a methane phenotype on a beef animal. There's work to look at converting methane to CO2 at the nostril. I'm not sure where that feature holds. And then other microbial strategies. So the point here is that none of these strategies are going to alone reduce methane to that 50% level that we're looking for. But I think the point is that we can combine those strategies. We have to look at the potential of combining individual strategies that are additive, that have different modes of action. And we can't focus on this silver bullet approach. We need to look at just low and moderate reductions when added together to give us that large reduction that we're looking for. So in terms of the way forward, I think methane mitigation is obviously part of it, the solution to achieving carbon neutrality. But we need to focus on intensity and reducing methanogenesis, because reducing methanogenesis is going to be important as we move forward. I think another thing we have to keep in mind is that reducing methanogenesis is not necessarily going to increase animal productivity. So there's going to be a cost for that. So in terms of the way forward, we need to figure out how do we incentivize producers to use those feed additives and diets that reduce methane that don't necessarily increase animal productivity. We need multiple strategies, as I mentioned, because ruminant production systems are very complex. So we're going to need different strategies at different times of the year, different production systems. And I think, you know, we've talked about this for so long, we really need to act now. There are strategies that we can use, especially for dairy and feedlot. I call these the low-hanging fruit, because we are dealing with diets that are highly managed and animal systems that are highly managed that we could incorporate feed additives and low methane diets. And the problem is the grazing animals, and there's very little attention being paid to that. We really need to ramp up our research and solutions for grazing animals, especially beef cow herds, because that is the real elephant in the room. And it's going to add to production costs, but as I think Jason talked about in his talk, there are potential revenues and offsets that can be obtained. So that's just my perspective on this situation. So with that, I thank you very much.
Thank you very much, Karen. And this concludes our three panelist presentations. And here's some more ground rules for what's coming next. We will break into groups of facilitated discussion. We'll have three groups. The first room's topic is the US beef and dairy sector can be climate neutral. The question is, how soon? Michelle Slimko from the National Dairy Council will facilitate that discussion. The second room's topic is public policy can incentivize an acceleration of climate smart solutions in beef and dairy production to reach climate neutrality. Dr. Agustin del Prado from the Basque Center for Climate Change, also IPCC member, will facilitate this room. The third breakout room will discuss how the livestock sector will see increased innovation and deployment of various mitigation tools to reduce greenhouse gas emissions from beef and dairy cattle. And Dr. Emilio Ongefeld from INIO Chile will facilitate the dialogue. Each of you have already been assigned to a room, so please accept the invitation on your screen to enter at around now. At 9:35 we will break, and at 9:40 we will regroup, and the facilitators will give a summary of what was discussed, as well as conclusions. And so with that, please accept your invitation and enjoy your breakout rooms.
Thanks for the quick introduction. I'm Michelle from National Dairy Council and the SVP for Nutrition and Environmental Research. Such a pleasure to be here today. I will be your facilitator. So glad to see everybody. Just a few just housekeeping before we get started. So want to encourage everybody to turn on their video, if that's okay, if that works for you. It helps to be in gallery mode so we can facilitate discussion. You can use the raise hand if you wish to speak, and you're in control of muting and not muting your speaker. So with that, I think we'll get started. Appreciate the presentation. Sarah, glad to have you in here as the lead presenter. The purpose of this breakout room was to look at US beef and dairy sectors and how they can be climate neutral. The question is how soon? I think we saw a lot of current strategies and future strategies. Maybe we could kick off with either some comments or questions related to that. I think the big question is how soon? What does that look like? What does the horizon look like?
Maybe I can say one word to that. Climate neutrality is a term that that is controversial at times, because this is not an attempt to make this industry no longer affecting the climate. We will affect the climate. The question is, can we limit additional warming, or can we stop additional warming in the future? Not can we get rid of all climate impacts of beef and dairy? That's not the question, and not the topic of climate neutrality. I just wanted to make that point so that nobody feels like we are greenwashing or making up some story here.
I'm not sure this is an answer. I think it's just a sort of random comment, but in my mind, it always depends how we assess it from a metrics point of view and a science point of view. And we've seen with the potential implementation of GWP star that that's got a whole new set of questions and challenges and implications for climate neutrality. So in some ways, I always feel like we need all the metrics and the methodologies in place before we can start making claims, because obviously science always evolves over time. But if we make a claim today and then we find the science is wrong or different in 2 years, 5 years, 10 years time, we may send farmers down a different route unintentionally. So we've got to be very, very confident in our science, I think, when we make claims about it.
Yeah, I guess I'd just say from an industry perspective, I think the reality of all of this is there's a few different buckets of things that need to happen or how quick it could happen, regardless if we define it as CO2 equivalents or CO2 warming equivalents or whatever, a total radiative forcing from the industry, however we define this in the future, right? So we know we're going to need emissions reductions, whatever pathway we take. So I think that's the key thing in some of those gaps that were identified by the other presenters, right? The big deal is, what are we going to do to lower emissions from grazing cattle? And I think that is a gap in terms of product solutions. So whether it's we have to think about how do we deliver additives and minerals or whatever else we're delivering to grazing cattle, or bolus form of delivery of inhibitors, things like that, I think are the practical, tangible product solutions that we need, along with all the other great solutions that Karen identified, right? Whether it's selective breeding. But then I think there's also the other parts of this that kind of relates to the point that you just made, that we need ways to track these emissions with confidence, whether that's through real empirical measurement or good modeling that everybody agrees upon is a good method to look at this over time. And I think that's going to be really critical as we move to the next phase and try to accelerate this, because as has been highlighted, right? There are going to be win-win reductions, but there are a lot of reductions that we can technically achieve that do not have an economic incentive currently. So we need to create a system that incentivizes market creation, whether it is offsets, or my personal preference is that we move to more of a carbon insetting type model, right? Where truly the supply chain invests back into the supply chain to reduce emissions. But all that will require a good methodology, right? And I think we can look at advancements that have been made, for example, in the beef industry, pretty rapid shifts in beef quality, for example, right? You have a lot more beef in the United States that is a higher quality grades USDA choice and prime now. And that's happened very rapidly because there was a market. And so I think on this environmental issue, we should look to those successful transformations of product attributes in the past and say, what can we learn from that to create systems that incentivize the changes that we want? And I think that's going to determine how quick it's all going to happen.
I think that word incentivize is also really key. I'm talking to you from the UK, but having worked in the States as well, I know we have the same problem, that we have some very motivated producers who will do everything they can, who will go to conferences, who will read articles, who will be up on the science. And there's always a proportion, let's say the bottom 25%, who, this is how I've always done it. This is how I'm going to do it. I don't see why I should change. Who's going to pay for it? Et cetera, et cetera, et cetera. So it's almost about incentivizing the bottom 25% to come up to the average or even past that, which in some ways will have a bigger change than incentivizing those who are already doing really good stuff and doing everything they can. So we've got to find some way to communicate with those who aren't interacting at the moment.
Imabile, if I said that correctly, did I pronounce your name correctly? I see your hand up.
Yeah.
Go ahead.
Yes, you did. Thank you for inviting me. I just want to share a couple of points. It's I think it's so obvious that beef and dairy industry will need to reduce the current level of greenhouse gas emission. Whatever the discussion can be around the methods, metrics to use, and so on, but it's so obvious that achieving climate neutrality will need some effort by all of us. So then the question is then how do we achieve that? So there is a issue regarding the policy. Do we have a proper policy to address that at all level? The incentives, so which form of incentives? Because we know that so far farmers do receive several types of incentives for different purposes. Are government or different industry willing to add additional incentives to add that? And then on the other hand, we need to think about the consumers, what the consumers want or what they desire, because we see different messaging that are going on every day, and some are quite accurate and scientifically valid, others are just propaganda. And of course, that creates also confusion and add additional pressure to dairy and beef industry. So I think we need a proper communication and really to understand at what level can we achieve. We know that just looking at the presentation we just followed, that achieving the neutrality will be quite difficult in some systems. So then how can we make sure that at least the overall emission from dairy and beef in US or Canada are reduced? So because so far most of our indicators are really showing the efficiency, how we achieve the reduction in emission intensity. But when you look at the overall, you see that farmers are always willing to expand their head because of course we need to agree mitigation has a cost, and that cost is sometimes very expensive for farmers. And we need to figure out how do we find the real market incentive to cover the mitigation cost. I think that is the big piece of the puzzle that's needed. I don't have the answer, unfortunately, but I think it's something that we need to do additional research on that to make sure that the cost of mitigation can be included in actual costs of production with really a clear return on investment that can convince farmers to adopt different practices. I stop here. Thank you for giving me the floor. Over.
Thank you for those comments. I think that talks about the complexity and all the things that are ahead of us. But it sparked another question for me. You talked about the importance also of communication. I wonder if there's any folks that want to comment on how you navigate this type of discussion. I think, Sarah, you talked about your NZI, like framing that discussion for NZI, the pathway, how to navigate that. And Frank, you talked about the complexity of it and controversial. How you navigate NZI with carbon neutral, climate neutrality with farmers or even the public. I mean, Imabile, you talked about all the different audiences. So I'm interested to hear any discussion or thoughts on how to adequately navigate communication of this.
Maybe I'll just say a word. Now the NZI, the Net Zero Initiative, is largely focusing on carbon neutrality. And while carbon neutrality is something that might be achievable for, let's say, the transportation sector or power production and so on, it will be extremely difficult to achieve, to be achieved in the livestock sector, simply because those animals will never stop belching and so on. So there will always be some emissions that cannot just be offset by, let's say, sequestration or so. but it's also not really needed to reach net zero carbon. What is needed is that we have strong enough reductions, particularly of the short-lived climate pollutant methane, that can help us to offset some of the other more long-lived climate pollutants. And so it is difficult to communicate that. And I know this because we do this with the Clear Center, very difficult to communicate, but very important. Because if we reduce methane significantly, then we really have an opportunity to reach a point in time in the future where these industries can no longer add additional warming to our climate. And I think that is what it's all about, and that's what we should focus on.
I think too, in the space of communication, there's an opportunity to a bit flip on its head what we as scientists and academic always trend towards, which is more education, but to actually build plans and programs and communication material from the ground up, and not just communication material, but actually involve and co-develop and co-produce these sorts of goals, strategies, allow producers to come to the table, pick from menus, ask for their input on, you know, what do you need help with? What they need help with might not actually be what we have identified as a specific mitigation opportunity. Like I would suggest that perhaps precision grazing, precision herding technology in the grazing system is another incredible opportunity to improve production efficiencies, enhance additional soil carbon sequestration, and, you know, performance and land utilization. Certainly in the beef cattle space industry more broadly. And I'm not sure that we're really always listening or asking maybe what they need help with, and then to allow sort of our scientific knowledge to connect those things to different mitigation opportunities or to different innovations like Sarah was mentioning. So I think that's critical. And I believe that as the producer, the older generation hands their operations down to the younger generation, that it will be an expectation of those individuals. All of them, the majority, I won't say all, the majority have gone to college. They're highly educated. They are engaged in a communication, you know, some sort of communication platform. They want to be involved, and they're going to expect and enjoy and look forward to that kind of engagement. And I'm hopeful that we are underestimating the potential for adoption and innovation if we can truly engage them and have an opportunity to kind of shift that culture.
Great. Michael, I see your hand up too. Did you want to respond?
Certainly. Thank you very much for the opportunity. And let me just caveat this with the point that I am not a scientist. And so my experience is a much more practical one, having worked for the last 20 years here on the ground with the California dairy sector. And so 2 points, one on the incentives piece of this, and California is probably a model in terms of incentives, because we have, particularly on the manure methane side, grants that are available from the state. We have credit markets, the low carbon fuel standard credit market, as well as the greenhouse gas reduction credit market. And we have incentives for procurement offtake in the form of energy, whether it's electricity or renewable natural gas here in California, that are very significant. I think the practical consideration for those of us on the ground is, and the credits are critically important, irrespective of the grants and the offtake incentives. Credits are critical. And it was very, I think, concerning to hear the point, and it's something we're dealing with. World Wildlife Federation statement during their presentation this morning about not being able to claim zero carbon coming from the dairy, whether it's zero or reduced carbon coming from the dairy. And how we solve for that's going to be very important, because our customers in the dairy sector are ultimately looking for the ability to claim those reductions in their own supply chain. So that's something I think that's absolutely critical that we get resolved in the short term. And then in terms of communications, and again, dealing with this on the front lines with the regulatory community here in California, we really need to start changing the conversation about methane. It's gotten, particularly here in California, what I think is a wrong rap, if you will, that it is a super pollutant because of its obviously more powerful in terms of climate warming. But we also know, as Frank has pointed out and others have pointed out, that it's much easier to deal with because of its short-lived nature. And so the real super pollutant in my mind is carbon dioxide because of its ability to accumulate in the environment and not methane. But we really need to change that dialogue if we're going to be successful. Thank you.
Thank you for that. One other common theme I heard within the three presentations also was this need for speed and acceleration. I'd be interested to also hear how you balance that out with the rest of the need for research, as research also takes time. So any thoughts on that, on how to balance that or trying to manage that expectation or think about some of the gaps left in the research areas as well?
Well, I think as was highlighted by Karen, right? There are things that we know we can do now, right? And so I think there's the acceleration is partially building these structures, as was just referenced across the board, right? Whether it's making sure that we're clear on what the actual barriers are to producers, and again, building the right reporting framework to essentially have a platform that as new innovations come in, it can plug into that, right? And so what I mean there is more, again, we don't have any way to track greenhouse gas emissions through supply chains right now, right? That does not exist. But yet that is what all these goals essentially require from companies that have been made or from industries, right? Is really good ways to track emissions in a much more real-time manner than, kind of the methods that are currently available to us. And I think that probably behooves us to focus on those type of things that we know we're going to need regardless of the path forward, right? To start accelerating towards. And again, those are the type of things that will give new technical solutions a place to actually flourish, right? From a standpoint of, hey, this gives an avenue for a new technology, a new intervention to actually have value because we have a system to value it, right? To monetize it in some way.
Jude, I see you nodding your head. Did you have any comments, or are you agreeing with Sarah?
I'm just totally agreeing. Yeah, absolutely. I mean, much as I think we'd like to get away from the who's going to pay for it thing, I think that's always going to be a consideration, because ultimately, I mean, there does seem to be a slightly odd perception sometimes, and I don't mean among this audience, but particularly from the consumer, that a farm should be there sort of just because the farmer loves it and it's great and we love the animals and the land's healthy and, yada, 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 and not recognizing that it is a business and it has to make money, and any practices that farmers implement have to have some sort of return on them. There are very few farmers across the world who can just go, yeah, I'll put a digester in, or yeah, I'll change this feed stuff that's 4 times the price. So we've got to have that economic balance as well.
Frank?
Yeah, you asked about whether research can keep up with what we really need. And if you ask me, I have to say I'm very kind of upset that while there is such a need and such a pressure to reduce greenhouse gases, particularly in animal agriculture, there is really no public support, research support that matches that need. The amount of federal or state funding to reduce enteric or manure or other emissions from livestock operation is dismal, and no, research is not keeping up. I mean, thank God there are people like Karen Bushman who started this 20, 30 years ago. And other than that, or otherwise, we would be at a really tough spot now. We don't have very much knowledge. We know some, but we are behind the curveball, and we need way more. And I'm not saying that as a scientist who is looking for funding. I'm saying that because we have a dire need to get more information quickly because time is running out.
Yeah, just to add on to all of these points, I agree with Sarah, I agree with Jude, and I absolutely agree with Frank. There is zero market signal coming to academics or research institutions, with the exception of industry. So to Jude's point, it's like these farmers are expected to not only implement mitigation strategies on their farms because it's the right thing to do, but they're also expected to pay for the research. And quite candidly, that's not getting the job done and really not fair. They provide food. I mean, this is a food security perspective and other wonderful services that they provide. This funding has got to come from other sources, period.
I see a couple hands up. Michael, I want to check in with you because your hand was still up, if that's old or new, or your...
Apologize, I'll take that
Okay,
off.
that's okay, just checking. Jason, I saw your hand up too.
Yes, ma'am, thank you. I think, I hope this is additive to the discussion, and your question was the perceived need for speed, the pace at which, I'm going to kind of loosely use the term reductions are required. Something that I think I have concern about, and it speaks to some of the things that the other panelists have mentioned with regard to metrics and evaluation. And certainly speaks to the methane conversation that many of us in this group have been involved with, over the last several years. We really, I think, have a fundamental lack of both understanding and the ability to describe the actual cumulative effects on temperature change of these activities. And this is a bit of a parsing of sources of emissions as well as species of emissions. And so, not to get down in that mess, but I think that when we speak about incentives, certainly in the US over the last 20 years, there's perhaps been disincentive in the marketplace toward what we might consider climate neutrality. So if consumers have a perception that certain production practices are environmentally beneficial, for example, elimination of intensively managed operations, right? And elimination of grain feeding, of confined feeding systems, et cetera, and are willing to pay a premium for products produced in those notably less efficient, more climate intensive systems, then I fear that we may be able to create perverse incentives for producers that actually fail to accelerate toward a goal rather than move toward it. So, I think that the discussion of incentives is important, but I also think that without the ability to truly evaluate the effect of these things on climate systems, that the likelihood is that we incent wrong behavior. And, a good example of that would be, some persons have spoken about the desire to eliminate meat consumption as a method to achieve environmental neutrality. And that's almost certainly the wrong message, right? So I suppose that I would encourage, groups like this to put forth, to emphasize Sarah's comments about measurement and Dr. Capper's comments about, how we evaluate. And perhaps we move less from a gross emissions and more to an actual climate effect as an outcome metric. And that perhaps that might be a path that would help us to devise innovations that achieve that true goal rather than sort of managing to the metrics. I'm not saying that that's necessarily achievable in the short run, but I might prefer accuracy over speed in some cases.
Thank you for that, Jason. I also see a comment from Kim to that. It's a good point. This is very true coming from food companies who have targets as well. Adibe, if I hope I said your name correctly, I see your hand up too.
Yes, thank you. I am Adibe from University of São Paulo, Brazil. I would like to make a comment is that the new farmers is the new generation of farmers are very keen on using the smartphones. So if we can, in one way or another, try to talk with these new farmers, these younger farmers, showing that through the cell phones, their smartphone, they can manage the grazing system, manage the animals efficiently, and we can start to have a generation of farmers or livestock producers focus in efficiency. And in non-developed countries where we are increasing the production but not decreasing or maintaining the number of animals. So what we need is to improve the efficiency in the small farmers with the livestock. And the easiest way to have this on small farmers will be, like Karen said, to improve the efficiency on using the pastures, having different plant species in the pastures. That's for the beef, but in the small or non-developing country, dairy cows also graze a lot. They are not on feedlot. So for the non-developed countries or smallholder farmers, I think improving the communication to the younger farmers, the new generation farmers, through the smartphones and improving for the grazing animals, grazing efficiency would be the way. For now, it will take longer to get, but I think we need to start.
Thank you for that. I think that's an important consideration. Imabwe, I see your hand up.
Thank you, Michelle. I just want to add one aspect that maybe we did not cover here. It's mainly focusing on the well-being of the farmers and the producers. Because as we discussed the climate neutrality or net zero initiative, we really need to understand that farmers, they are doing a tremendous job taking care of the animals, but also managing the farm, maintaining landscape and so on. And usually they are not well associated with those debates on climate neutrality. So therefore, consequently, that it really increased much more pressure on them, because as we have already identified from this seminar, is that we see a challenge. How do we finance this? Which type of incentive and so on? But we need to involve them to make sure that we are really not kind of increasing much more stress or pressure on them by asking them to do the impossible, because we know that farmers have achieved a lot in the last 50 years with the adoption technology, change in management, improving the breeding and so on. So they have achieved a lot. And we know that in some countries, usually farmers work on contract. So they are also the industry standard that they need to fulfill. They are the policy requirement, the pollution requirement. There are too many requests that the farmers really need to fulfill. And then I think the climate neutrality is one of the pressing. And the issue is that the solutions are there, but we know that are somehow difficult, and we know that we cannot achieve the neutrality or the zero emission, as Frank mentioned earlier. So we need really to make sure that farmers do understand what we want to achieve, and they do a buy-in in this. Otherwise, I think it would be a lost battle if we don't really involve the farmers at early stage of this discussion. Over. Thank you.
I saw a build of a comment from Kim that she agrees with you in the rural communities that depend on those farmers. It's very important. I'm just looking at the chat. There's a side chat too. Jason chimed in, should a portfolio of environmental impacts / benefits, oh wait, it moved, be considered, i.e. environmentally neutral versus climate neutral? Anybody want to comment on that?
This is Greg from University of Arkansas. I just posted in the chat real quickly about Jason's thought on environmentally neutral. So one of the criticisms that I frequently hear about sustainable intensification is that it doesn't fully account for ecosystem services that can be ultimately harmed by the continued intensification, right? So this continual push for higher and higher efficiency can come at a cost that's not always well accounted. So I agree with Jason that it might be useful to think more broadly than just climate, right? Because certainly we know that.
I'm about to talk.
Yeah. Anyway.
Sorry, I think I came off mute a bit too soon there. I didn't mean to. I just wanted to agree and say that we've got to think about this on a global basis as well. If we look at a lot of smallholder operations, particularly in the lower and middle income countries, if we simply look at carbon footprint as the sort of arbiter of whether they should farm or not, we come up with a very different answer when we look at ecosystem services, land use, and things are outside environmental in terms of the social, the cultural, nutrition, income status, etc., etc. So I think it isn't just that we have to go beyond carbon into other environmental metrics, but we have to go past the environmental and look at all the aspects of sustainability as well.
And one.
Oh, go ahead, Greg.
Yeah, sorry, just to follow on Jude's comment. It ultimately comes to incentivization, right? How can we incentivize the farmers to do these things? And their fundamental nature is to care for the land. I mean, if they don't care for the land, then their legacy is destroyed, right? We know that from the 1930s Dust Bowl, right? You have to care for the land. So this focus that we have on, we have to reduce the environmental impact if we can figure out the economics and social piece of this, the environment will benefit automatically because that's what they do, right? They don't go out and destroy the land because they want to destroy the land, right? It's just we're backwards, right? So how do we reimagine the fundamental structure of incentives so that farmers can do the things that they want to do the way that is beneficial to the environment in the long term, and make a living, and support rural vibrancy, et cetera, et cetera. I think I come from the environmental sustainability world, right? So, I think that's important as well. But I also think that you can't force feed. Just can't force feed it. It always comes down to the incentive structure and how do we reimagine that? And I don't have an answer, but I have some thoughts that I probably can't say in public though.
You have lots of comments in the chat box. I don't know if Kim or Jude or Sarah want to weigh in. Let's see.
Yeah, I think it's just building upon everything that's just been said, right? Of I always get a little frustrated in these kind of forums where people are critiquing the food system wherever it is in the world, because that's kind of the gist of my comment, right? Essentially, farmers are just reacting to what the signals are. Give it to me cheap, give it to me consistently, et cetera, et cetera. That's led to intensification, and then people are like, "Why did you intensify? This is terrible," right? So it's like that's where we have this disconnect between the overall market signals of please do this, right? Of please give it to me cheap, etc. And then this sometimes a minority saying, no, we don't like that, right? So we need to be able to reconcile all those things. And I think it is possible, but it does come back to, as we've kind of come back to before, like we got to pay attention to the on the ground lived experience realities of farmers. And you need good ways to actually measure these things to start moving the needle, because otherwise it will just stay in a forum like this where we just talk about it and nothing changes, right? You need to actually get something delivered on the ground that starts changing the way supply chains function, the way they incentivize different activities.
And we also need help on the research side to get ahead of it. So we have a start here, because I'm not sure we have that right now, right? Producers, the most progressive, like Jude was saying, they come to you and they say, how can I begin? And my answer is always, well, where is your ranch, right? Like where are you working? And then, so there isn't a start here. I mean, sure there is, but are we sure? I don't know.
Yeah, Greg, I think your comments made me think too about Sarah's slide. Sarah, you have the one with the 3 circles of the complexity, and you have environmental, economic, and social. One of the questions I had too was, and Greg, you just brought it up, the importance of looking at that economic lens as well. Do we think, or maybe this is for Sarah, do you think those 3 areas of sustainability need to be more well developed? Do they talk to each other well? Are we looking at multidisciplines? Are the folks in dairy and beef thinking about that? But we need a little bit of that balance. So I'd be interested to hear your perspective as you created, as you put them all together.
Yeah, so I think there are some examples of where we are really trying to look at those trade-offs, but I think, and some of those trade-offs were mentioned by the other presenters, right? The classic one of ruminants, right? We can feed them grain and lower their emissions, but then we're not maximizing the value of their ability to convert human inedible feedstuffs, right? So that's just one, like within the environmental realm. No, I think that's a great example of some of this other research that is squarely in the public domain. And the comment that was made earlier, essentially we have increasing public interest in this space, and we do not have an increase in the funds to actually do this really meaningful work, right? So some of it can be achieved through public-private partnerships, and I think there's some good work happening there. In the US, the Foundation for Food and Ag Research is one avenue to try to tackle some of these trade-off questions and some of these bigger issues. But I think there's a lot that we don't, we just don't talk about, frankly, of there are trade-offs, right? And I think that's what's key, is that you have to grapple with them, that sometimes you can't have it all. And so we need to be able to lay that out clearly. And I think that's where sometimes these sustainability discussions, we can easily talk past one another because people are valuing certain aspects of sustainability differently, right? And this whole discussion is not objective. It is chock full of value judgments. And so we just have to be very, very clear about that, right? There is not going to be a single perfect answer. So we do have to just say, we're going to have to settle with being directionally correct and trying to move forward, right? We don't want to, that's the other hazard of talking about all this complexity, is you just are like, throw up your hands and be like, well, what can we even do, right? We do have to start doing something. And we know we have to work on climate change. We know we have to reduce emissions, right? So I don't want to like back to the point of this, like we have to reduce emissions, right? So how can we actually achieve that? We can be focused on that and then be frank with ourselves about all the other trade-offs that exist and say, how do we take that trade-off and turn it into a win-win?
Did I do my job? Did we answer the question of how long, how to get to climate neutrality? I think I had a really good discussion on a lot of the key themes for considerations. I just want to bring that back to the original question, how, thinking about how long. Jason, you have your hand up too.
Sorry. Yeah, I was actually, when I raised my hand earlier, I was trying to be mindful of, and maybe I should say a sentence about that question, since I don't know that we talked about it directly, but I think that the timing of when the beef and dairy value chains can be quote unquote climate neutral does depend on how we choose to assess and measure it. And that depending on that frame of measurement, we could make the argument that it has been climate neutral for some amount of time in the past, or that it could be imminently achievable, in other words, within the next 20 years. Under other frames of measurement, however, we could argue, for example, if we considered only gross emissions and never any internalization or offsetting, then you could argue that it's unachievable. And so I think that really the answer is it could be achievable. It could have already been achieved. It could be imminently achievable, or it could never be achievable. And all of that is dependent upon the frame of measurement. And so the conversation that we had today about evaluating trade-offs, and which to me is a frame of measurement, right? How do we put boundaries around the system, becomes the essential question in determining the timing of neutrality.
Frank?
Maybe just a really quick comment on this. So Jason, I couldn't agree more with what you just said. And to answer your question, Michelle, when will we be climate neutral? The FAO has a task force that's active on answering the question of how do we deal with methane? How do we quantify it? What are the impacts on climate? And so forth. And the final report will come out in a couple of months. So that final report will probably help us answering that question. And I see
Thank you.
We have 1 minute left here.
Oh, Michael, you have your hand up. Sorry.
Yeah, thank you. Real quickly, since we're running out of time, I think we've had asked that same question here in California with the dairy sector, and since we've seen declining herds here in California, just under 10% since 2008, we're probably already getting close to a point where we are methane neutral. To truly, I think, be climate neutral, we're going to have to reduce methane enough to also mitigate or offset the impacts of the other emissions we create on dairies, carbon dioxide and nitrous oxide. But I think that is something that we hope we can achieve by 2030, and I think that is highly possible.
Okay, I think with that, we need to conclude. I got a note that it's to leave the breakout room. But thank you, everybody, for the great conversation. And I think if you got it, you have 83 seconds to leave the breakout room, it says. Thank you, everybody. I really appreciate everybody participating. Thank you.
Thank you.
Well, first of all, thank you everyone for being here. Good morning or good afternoon. And thank you, Karen, for your presentation. It's a very exciting topic. I was thinking in starting with very brief introductions, name, affiliation, and area of research. I'm Emilio. I work at INAA, Chile, and I work on rumen metabolism. I don't know if anyone else wants to go ahead, or can you unmute?
I'm Tim McAllister with Agriculture and Agri-Food Canada and Lethbridge, and we've been working in the area of mitigation of enteric methane emissions in beef cattle for some time. Latest work we published is examining biochar and whether it can be used as a approach to lowering methane emissions in ruminants.
Okay, I can go next. I'm Dipti Pita, an associate professor from University of Pennsylvania School of Veterinary Medicine. I work on rumen microbes, and my interest is in understanding ruminal methanogenesis. I also try to compare methanogenesis to other ecosystems. We have USDA funded projects that are focused on looking at how the microbiome compares between high and low methane yield phenotypes in dairy cows. And we have also been looking at how the effect of 3-NOP and Asparagopsis interferes with ruminal methanogenesis. Yeah, look forward to the discussion.
I'm Robert. Oh, sorry, Emilio.
Go ahead.
Thanks, Emilio. Robert Burns. I'm a distinguished professor at the University of Tennessee, agricultural engineer, and work in the area of manure management and treatment and quantification of gaseous emissions from livestock systems.
This is Will Horvath. I'm from UC Davis. I'm chair of the Department of Land, Air, and Water Resources. I'm a soil biogeochemist, and so I've been working on eliminating methane emissions from lagoon storage, and that's with metal coagulation, and then also looking at nitrous oxide and methane emissions during storage, and then the application of processed manure into different products to move off farm.
I'm working with Agriculture Agri-Food Canada. I'm dairy nutritionist, working also on mitigation of enteric methane. We use we evaluate different strategies, including feed additives like essential oils, tannins, forage impact on enteric methane, lipids, and so on. So happy to be part of the discussion. Thank you.
Yeah, I can go next. I'm Rui-Hong Zhang. I'm professor at UC Davis in the Department of Biological and Ag Engineering. I am an ag engineer, and I have been doing my research in animal manure treatment and other organic waste treatment as well. And for manure, and a lot of my research has been anaerobic digestion for biogas production and treating manure to reduce the methane emissions in lagoons, and also converting animal manure into high-value fertilizer products. Happy to meet you all.
I can go next. The Chief Science Officer at the California Dairy Research Foundation. So we are a funder of a lot of the folks who are on the call today. I'll just stop there because my internet looks unstable.
Hi, this is Yan Sun. I am a senior technology lead of sustainability in cargo animal nutrition. My focus is on methane reduction at this moment, and my role is really a good combination of technology development and business factors. So our goal is really to investigate how to develop technologies and also in the meantime to create profitability for farmers. So very nice meeting everybody here and looking forward to the discussion. You may see a cattail wiggling in the background. I apologize for that. That's my cat. Sometimes she just like to show everybody how, yeah, she wants to say hi.
All right, and I guess we all met Karen already. So is there anyone else? Okay. So let's start the discussion about what's coming in the next years in terms of tools for and strategies for decreasing enteric methane production. I want to start by thanking Karen for her presentation. I don't know if you have any questions, any follow-up questions for Karen or comments.
Well, I think Karen presented a pretty balanced approach, emphasizing that there isn't a silver bullet, that the combination may be a way to achieve higher levels of reduction. Although I think at this point, we don't know how additive those things are when we combine them together. There's definitely an area for research to explore those possibilities more. But I think from the presentations we saw, like it's sort of like, yeah, we can make some reductions in methane emissions and contribute towards carbon neutrality, but methane alone is not going to achieve that. And we shouldn't be trying to propose that it's going to, otherwise we could be giving a false message.
Mm-hmm. I hope that was part of the point that I hope that I was able to convey that. Like, I agree with what you said, Tim. I mean, reducing enteric methane is going to have a large impact, and it's a noble pursuit. But I get the impression that there's just too much emphasis on enteric methane. It's really going to be tightening all the gaps in all the different parts of the production chain. Reducing where we can, and 50% reduction in methane that we often hear about, or 30%, that's going to be a really uphill battle to try and obtain.
Yeah. I would add and say that go further and say that not only methane alone is insufficient, but with some of the strategies that we are investigating, we may decrease methane and increase the emissions of other greenhouse gases. So that we have to be quite careful and take that into account, and also progress in research with the LCA, the life cycle assessments that have to be very targeted to different system productions, different regions, different countries, different places. So I think that aspect is quite important.
Emilio, I would add, if you look at the literature, most of the studies on mitigation of enteric methane emissions, we even didn't look at the effects on manure emissions, especially methane. And there were, for example, we did some studies, and we observed that although sometimes we were able to reduce methane, sometimes enteric methane, I mean, sometime the gain achieved via this reduction is completely or sometimes partially offset by higher emissions from manure storage, for example. And we saw that with adding lipids, with forage, using different type of forages and so on. So this is very important. So this maybe help to, as Karen said, that even when we focus on just enteric methane, just with I mean, look at the animal level. If we focus on just on enteric methane and manure from animal, it can lead to higher emissions. It's like we are losing like a big part of the gain. So it's like even we succeed to reduce enteric methane by 30%, if it increased methane emissions from stored manure increased by 15%, it's like we are losing gain. So this is very important to look at this type of effect, to not just focus on enteric methane.
Thank you, Joe.
Yeah, I would like to second that importance as well, and reducing the emissions from manure systems or manure management. And just a couple points I wanted to comment on, and looking at the feed additive for reducing enteric methane emissions. One of those is based on the providing nitrate and into the rumen, suppressing methanogenesis, which is a great approach. But the one thing I have not seen data, or maybe Karen, you have seen data, I have not focused in that area, is the nitrous oxide emissions. When you put the nitrite into the rumen in a noxic environment, so I wonder how nitrous oxide emission is from the cows, and see whether any data have been collected in that regard. And so methane emission is low, but if there's a nitrous oxide emission high, so there can be some problem there. So it'd be good to collect some data if the data not there yet. Then the other one is for feed additive adding to the into the rumen, and if the residual coming out in the manure, and that may affect the methane production in this biogas system and our digesters. And there has been a lot of investment in our digesters for producing methane, which is make sure the feed additive residual in the manure will not suppress significantly methanogenesis in the digesters. That's where digesters build to produce methane. Yeah, and probably another third point is we definitely need to continue to really looking at the work with the manure as bioresources, and manure is one of those commodities produced year-round consistently, especially in these feedlots, right? Not in the grazing, well, even manure laying by the grazing animals. So we really need to work on converting this manure, look at this manure as a bioresources, and convert them into valuable products, including energy and fertilizers. And so I think that's where you will take a more work, more emphasis. And overall, you will reduce the carbon footprint and reduce the methane emissions.
I would agree with that. It was interesting in that World Wildlife presentation by Jason in their model. It seemed to me that the biodigester was a real big part of the total carbon neutrality scheme of reaching carbon neutrality. It came down to generating fuel at the dairy level, and I just wonder, maybe Robert or I don't know if somebody can comment on that. Like, what size of dairy farm do you need to have a biodigester that could produce sufficient fuel that you're not just generating fuel for your farm, but you're generating fuel for the grid? I mean, their scenario was a very large farm with an average, I think, 3,000 cows. But what about smaller farms in Wisconsin or other parts of the world?
And we've certainly installed digesters on smaller facilities, and I think the limiting factor now has been the economic viability, right? We've looked for years at how do we utilize that energy, whether it be in heat or electricity, and a direct offset, to offset the production, the purchase of other energy. But now we're seeing with the projects I'm being called about right now are basically being driven by CARB funding, right? There's a great interest in that, because with those subsidies, they can make those systems cash flow. They're looking at gas cleanup to go to RNG. In Europe, we've done this for many years, and gensets going to energy. In terms of dairy size, Rayhong, you probably are have worked more directly with that.
Okay, well, thank you, Robert. Just add to that. Yeah, in terms of size there, right, it's driven by economics. But the one thing which is really enlightening is about the renewable natural gas market. And for small dairies, digesters we can build digesters, very complicated, sophisticated, high cost, or we can build the low cost digesters. And so there are these digesters available, but for small dairies, we may not be able to build the fancy digesters. However, and a simple digester produce methane. But the methane, if it can be collected, put into compressed cylinders and transported into these hubs, right, into the biogas or renewable natural gas hub or pipe. And Karen, I believe you mentioned about the clusters of small dairies, and then have biogas processing hub, and now have these smaller quantity gas piping to centralize the station to help to process it. And so make these system clusters more economically viable. I think there are these approaches once the market is there, and then our dairies and technology developers, investors become innovative. And I see there's a lot of opportunities for smaller dairies as well as for large dairies as we move forward.
Yeah, I would agree. We're looking at moving brown gas via, short line rail, right? Different ways to move it to the RNG cleanup plant, which is a larger cost there. That I guess the thing that we've talked about, and Emilio mentioned it, the trade-offs. So we take that digested manure, and then we ultimately, I would land apply it in the systems I work in, right? The system that Dr. Clay talked about looked at making some higher value fertilizers. But if we go back to that basic circular nutrient cycling of taking those nutrients and going back to the ground and producing crops, then we get in this situation of I'm a large proponent of manure injection, and have spent many years of my career encouraging producers to inject manure. But yet when we look at the research that's going on, we see that injection of manure below the soil surface will typically trigger increased N2O emissions. And then I think the trade-off gets even bigger, because we say, okay, we may reduce some methane through the digestion process, stabilize the carbon, and then when we inject that manure, that nitrogen triggers N2O emissions. But there's other trade-offs, right? Injection, we also reduce odor emissions, reduce ammonia emissions. So the control boundary gets larger than greenhouse gases, right? We have to think about the entire system holistically and say, are we willing to say just for N2O that we're going to give up, odor emissions, ammonia emissions, all these other good benefits that come from that. And then obviously your life cycle analysis get even larger, because most of the studies that I've dealt with are not life cycle LCA studies, they're emission studies. And we go out and we measure comparisons of emissions, say from manure versus no manure application versus commercial fertilizer application. And we say, okay, we see the emissions typically from manured ground will be greater greenhouse gas emissions than from commercial fertilizers. But then when you draw that control boundary and say, okay, let's think about the energy, right, that went into the Haber-Bosch process to create the commercial fertilizer. So it really is complex. And I think we have to think about not only antagonistic greenhouse gas emissions, right? We may reduce one to get another, but we have to think about the whole system, odor, ammonia, all the social and environmental aspects and economic aspects that go with it is bigger than just the greenhouse gases.
Soil health, I think, would be part of that too, when you look at manure.
Absolutely. Right. We'll talk about the ammonia being a precursor to PM fine, right? And say, what's the benefit from reducing it compared to that trade-off of perhaps we increased nitrous oxide.
I think that's a critical message we need to coming back with is in terms of livestock and how they integrate into the food production system. And it's more than just greenhouse gases. And that was touched upon in some of the talks as well. And I think we need to keep emphasizing that, the role they play in a circular economy. Many of the byproducts are food, which would be designated as food waste, the utilization of those to produce food for humans. So I think those are important messages that we don't want to lose sight of. When you look at negative impacts from a sustainability perspective, then the greenhouse gases, it's hard to make that look positive. But there's many other aspects of having livestock involved in food production systems that are definitely positive.
Tim or others, I'm just going to throw this out. Do you think we're chasing the wrong target, trying to reduce enteric methane emissions, especially from grazing animals? Certainly in a beef feedlot or in a dairy where we have precision feeding and the potential for using feed additives, that's a no-brainer. But in a grazing system where we have especially extensive grazing system, is it realistic to expect that we can reduce enteric methane emissions without causing other undesirable environmental impacts?
We're probably much behind in the research, because really most of the research, if you look at the proportion of the papers methane mitigation that have been conducted in grazing systems, that's is less than 10%, I think, where we recently quantified it. So I think we are lagging behind in the research, and some of the strategies that are being investigated can apply potentially, like vaccination, genetic improvement, to grazing systems. Although so far the results are very mild or moderate at the best. But I think that in terms of additives, like the NOP, will have to think in very slow release devices or blocks with molasses or salts, and start looking at those options. I think that the proportion of the efforts, that the research efforts dedicated to those systems is it's a lot lower. So I wouldn't rule out the possibility that effective strategies can be developed at this point for those systems. We need more effort, probably. I think it's a central point.
I think follow up what Emilio just shared. For the grazing situation, there are many challenges of why we're still behind. One thing is really challenged to make sure the animals have the designated intake dosage of the additives, if there's additive solution. Another thing I think is very important is the profitability of the grazing situation is by itself is low. And if there's any additional technologies require the farmers to pay more money to implement and to reduce methane without significant incentives, it's really hard for them to adopt this technology. Therefore, it's really a hard bone to chew on. Not many researchers or companies are willing to investigate further in this space. Whereas for feedlot, for dairy situation is more intense, the production system, it's sort of not really low-hanging fruit, but it's easier to tackle those issues. That's how I see the possible problem is. But I think from technical point of view, we all know that for grazing situation, there's actually higher potential to reduce the greenhouse gas emission. If we can do that, then the total greenhouse gas emission can have a great extent of reduction. What we can do is, I think I wanted to share some of my thought, and I wanted to hear the others' opinion is also, I think as researchers, as the group who's working on product or technology development and innovation, we can also educate the outside, the whole supply chain, that realistically, there's no silver bullet. There's still a lot of stakeholders on the supply chain. They are not aware that there's no silver bullet. Think about last year, Burger King has these commercial outside, right? Lemongrass. All the researchers know it's not possible, but it's not very clear to some big food companies. And also, I think giving them realistic expectation and let them know what is the high potential area can increase their interest on working on a specific area. And also, I think to educate the policymakers, what is the realistic area and more urgent area to work on, and increase these collaboration between researchers and with the industry stakeholders, and connect with the farmers to learn, okay, what is the more realistic way to apply technologies and how to create profitability for them? What is their interest in order to increase adoption? And thinking about all of these, it's really a lot to do. Maybe instead of doing research on dairy and beef, maybe it makes sense for a certain technology, we focus on beef specifically, feedlot, or beef specifically on grazing situation. When we finish from the feed, productivity, and manure production, the whole life cycle, after we finish the whole thing, then we leverage the opportunity to other species instead of making it too broad, and then we see a lot of gaps still existing and not a lot of research, enough research to fill those gaps. Just some thought I want to share here, and I'm looking forward to hear your opinion.
Mm-hmm. I think you made some fantastic points, and as a researcher myself, I think it's very difficult to obtain support and funding from the type of research that I think really needs to be done, where you're looking at very moderate reductions in methane, and it's not, the silver bullet approach. Whereas if you can come with, Asparagus, we're going to reduce methane by 98%, bang, people are interested in that. But when you talk about, species composition of pastures or tannin containing legumes in pastures, it's very, people say, well, why should I invest in that? I might get a 10% reduction in methane. So I think in a way we've done it to ourselves as researchers. We, at the beginning, we sold, if we reduce enteric methane emissions, maybe the animals are going to grow faster or more efficient. And we've now started to see that in most cases, there is no production enhancement by reducing methane emissions, with some exceptions. But you're right, the industry has large expectations of they don't want these small incremental improvements, right?
I think Robert has his hand up.
Yes, so what I would like to add upon is, I would agree with Tim and Karen about there's with everybody there's no silver bullet, but also with Emilio that we're lagging behind so much in research, and we have so many additives out there, so many strategies out there, but understanding methanogenesis in the rumen is so very important. So when we're talking about methane formation, there's not like one microbe that's responsible for methane formation, that there's several methanogens that compete with each other. And it's so important to kind of, as we're talking about like tannin containing forages or different feed additives, some could be selectively inhibiting methanogenesis. For example, Asparagus seem to inhibit specific species of methanogens. And so who are the actual role players, who are the contributors for methane formation, and how does different feed additives or feeding strategies influence these microbial populations is so very important. So understanding methanogenesis and who are the contributors to total methane formation is of precedence in order for us to understand, even like comparing beef cattle or with dairy systems or grazing systems to conventional total mixed ration feeding systems. I think it's important for us to understand the microbial metabolism, the role of methanogens. That's level one. And then because methanogens cannot exist on their own, they exist in a symbiotic relationship with either bacteria or protozoa or other microbes. And any sort of implications that, or any sort of strategies that we bring to feeding systems are going to affect methanogens and ultimately either the bacteria or protozoa, which is going to have a rippling effect on production performance. So we have so many strategies. It's important that we bring the research context into the front to match what's going on within the rumen. And now we have those technologies. So I think getting there, deep dive into rumen microbial metabolism to understand methanogenesis is one way to understand like what are the different strategies that could be complemented to achieve both reduction in methanogenesis as well as making progress in production efficiencies.
Thank you, Dipti. Yeah, in that regard, it's something important to understand with some additives like 3-NOP, for instance. In some studies, we see a 30-40% decrease in methane, for instance. And okay, but the rest of the methane, there's some methanogens that kept producing it. So how did they do it, and why those ones are not being inhibited? Or is it that the same methanogens are producing methane, but just at a lower rate?
Yeah, but for example, we have found that there's a difference in methane emissions by 26% between high and low methane emitting phenotype cows. And also with 3-NOP, we found about 26% difference. And so when we looked at the methanogen pathways, they seem to be similar. So I don't know whether trying to complement 3-NOP with breeding strategies would be any effective, but when we try to look at seaweeds or Asparagopsis seem to have a completely different effect on methanogenesis. So then can we try to complement low methane emitting cows with feeding seaweeds? Yeah, there might be further reductions in methane emissions. Yeah, so I think it's really important to understand. It's not only like what's happening to the total methane emissions in a 24-hour period. It also depends on the feeding patterns. In kind of grazing systems, animals are continually feeding. And so how is that affecting the microbial populations? Whereas in a total mixed ration conditions where cows are fed once a day, you see a bulk of methane emissions coming during the first 6 hours. So who are the role players and how are they contributing? Should we kind of determine the dose levels of these feed additives based on the composition of methanogens is something that needs to be investigated.
I think some of the challenges, the more complex that you make it, the more difficult it is to implement some of these mitigation strategies. So like in our intensive dairy operations where we're feeding a TMR and there's quite a bit of commonality in the procedures, although there's still differences in diet composition, some of those additives may be more amenable to be used under those conditions. But when you look at beef cattle, which graze, or produce mainly on landscapes and are adapted to the various environments that they have, some of which are very dry and hot and some of which are very wet and colder. So you need to, I think, adapt the animals to those environments first if you're going to get any kind of efficiency, regardless of the implications for methane emissions. But if we look at some of the data that was presented, you can see that in the developed countries, we're doing pretty good at reducing intensity. And where the issue is really in the developing countries where there's huge emissions with very low levels of production. And if we're really going to make a difference, and a lot of the cattle are in those environments as well. If you look at the global populations, if we're going to make a difference on a global perspective, we can't ignore, having an impact on those developing countries, because they're the ones of which are contributing to an increase in emissions under current production practices. So does that mean we intensify the entire world, or what are the approaches to that?
Would intensifying per se assure that absolute emissions are
Well, that's the other debate. I think, like the easiest way to lower ruminant emissions from ruminants is not to have any, right? So, and that's what some people are advocating for, but that's where the role of livestock needs to be considered as well, in terms of the ability to ruminate. Even, I think most people don't realize, like, even in the intensive systems in North America, when you talk about beef cattle production, 80% of what's fed to the beef cycle is still forages,
Yeah,
food sources that are not suitable for human consumption.
The other point is, I get the sense in the developed countries, or at least in Europe and North America, or Canada and US, there's a move toward, for beef, there's a move towards a push towards grass-fed and elimination of any technologies, no implants, no feed additives, no. So there's a move kind of back to a less intensive system, which is actually, I'm not sure what's driving that, but actually that will ultimately increase greenhouse gas emissions.
And so that, Karen, I had a question for you. I noticed in your presentation, you made the point that 80% of enteric methane comes from those brood cattle rather than feedlots. And where I'm located in Tennessee, there's not a move back to grass-fed. We're all grass-fed. We have an inventory of about 1.8 million animals in their cow-calf operations. In fact, I was raised on one of those operations and farmed it, managed it for 6 years with about 200 brood cows. And the tools that we talk about in working here with anaerobic digesters and these feeding additives, they're not tools that are available for those types of producers, because we grow that many cows because we're good at growing grass. All those calves then are shipped to feedlots in Iowa, Nebraska, and Colorado for finishing. But here we're growing animals on grass. And when people say, okay, well, what tools do I have to reduce greenhouse gas emissions? Other than, perhaps nitrification inhibitors, I don't know what to tell them, because we're in systems where the animals are completely grass-fed. There is no managed feed per se. Yeah, and the manure is not collected. The manure is distributed by the animals.
Absolutely. And that's the challenge with beef cattle production. So when I was looking at that system, I was looking at the emissions from the cow-calf, and then following the calves through what you said, they're shipped and then they're finished in feedlots elsewhere. So when we look at all that cycle together, I mean, those numbers are going to be plus or minus, but it's basically at least 70% of the emissions are from the cow-calf herd, and mainly from the cows, because they're there year round, eating and breathing and producing methane from a forage-based diet. And that forage diet is often very low quality, intentionally, because we don't want to be feeding it those animals are, best quality forages that can be fed to dairy cows and other other animals with high energy demands. So that's right. So most of the emissions are from exactly what you were talking about, those beef cows maintained on low quality feeds. And feeding additives is not going to, it's just not going to be part of that solution in those extensive pastures. So there's the problem. We have to look at changing the way we graze those animals, what the species composition is of the pastures, and more importantly, for places where they're not grazing 12 months of the year, where they have a period, either a dry period or a cold period, winter feeding, whatever, look at there's opportunities for supplementation there, where we're actually providing feed. So there's no one solution for beef cattle. We really have to look at a seasonal approach, and it's really going to come down to the management of those animals.
Thank you. It's good discussion.
But yeah, we have to start wrapping up. We've got 2 more minutes to go. Yeah, so this has been pretty fast. So I would say let's keep it to the big messages. I think we agreed that we need a holistic approach and look at pretty much everything. We talked about manure a bit. We've been also discussing the beef and the extensive systems as one of the central problems, and that pretty much overlaps with what happens in developing countries, and the difficulties to find strategies that are applicable to those systems. I think personally, I think there is a lot more research that needs to be done for those systems. We talked about a bit about methanogens, how different methanogens respond to our interventions.
Emilio, on that point, I think a very important point about how methanogens respond to interventions is I think we need to stress, because that's going to help us understand what strategies are complementary. And I think Dipti made that point, and that's something we need to make in our final statement. It's not just because we want to understand the methanogens, it's really to understand how then we can apply different strategies and what the best doses are, et cetera. So it's really the basis for mitigation.
Right, and how to target them all. I think, yeah, we are pretty much done with the time. So we have to reconvene with the larger group. So I'll see you there in a few minutes. I guess I have 5 minutes to try summarize the discussion, and I'll meet you there in a wee bit. Unless someone wants to add something else before we leave.
Also about the global scale that Tim pointed out.
And just for everyone, if you want to continue any part of these conversations, I'll be sending a follow-up email where I will connect everyone via their emails. Thank you so much.
I'm just going to indicate just some housekeeping rules here. I mean, you can all leave your cameras on, so we will all see what's going on around you in your cameras area. And also, if you want to talk, you can always mute and unmute. I suppose you all know how to do that. So I think this is all easy rules for this breakout room. The idea is that I don't speak too much, but you mostly do the talking. So I'm just here to try to facilitate if there is a lot of if there is too much silence. So if anyone wants to speak about the subject, just the first time, I would appreciate. I think we would appreciate if you introduce yourself. Okay. So so I had some questions that were relevant for other room, but I think it's the same. It's going to be similar for policy perspective. I mean, when we talk about climate neutrality, and actually the three panelists have already been very useful because they have introduced several of the thoughts that I had in mind that could be debatable, and one of them was actually the term neutrality. So already Sarah already mentioned that if we actually thought of neutrality in terms of net zero CO2, it would be almost impossible in comparison that if we thought in terms of CO2 warming equivalents. So, I mean, one of my first questions, because I work in Spain, I have worked all my life in Europe. I'm obviously aware of some of the stuff that is happening in the States, but it's not really my context specifically. So it's I would just wonder if this is something, this common approach on neutrality is something that is taken by the sector as a shared vision and with a shared definition. I would also ask you guys if how the process is happening with the policymakers. Is this is there like a plan already happening where the different sector actors are engaging very fluidly with the relevant policymakers in terms of climate policy and agricultural policy? Well, that would be my two first questions. You can always divert to other opinions and other things. So anyone want to start?
Sure. Hi, good morning. I was wondering, since we are a relatively short group, if it would be helpful to just have quick introductions. My name is Geetika Joshi. I work in the California Department of Food and Agriculture. And the state of California does have very specific legislations in place for reduction of greenhouse gases, as well as specifically for methane from dairy and livestock sector. And between our different state agencies at the California Air Resources Board, as well as the Department of Agriculture, there's a lot of work ongoing on stakeholder engagement, as well as incentivizing and providing funds to dairy producers to implement methane reduction strategies. But most of them currently specifically focus on manure management rather than enteric fermentation. So I will just very briefly say that and leave that here. You know, we can talk about the details of those legislations and policies or processes as needed. And yeah, just throwing out there if we should do intros. Thank you.
Okay. We know already Jason from the rest of the group. Is there anyone else that would like to introduce himself or herself?
Sure, I'll introduce myself. I'm Allison Eagle. I am a senior scientist with Environmental Defense Fund based in North Carolina. I work on nutrient management and agricultural greenhouse gas emission reduction, translation, synthesis, and that's that kind of work for. And so I've been drawn into the livestock methane work in the last while, as well as the other agricultural greenhouse gas emissions.
And I'm Kevin Esslinger. I'm at the California Resources Board, and I do the greenhouse gas calculations for livestock for the state of California.
Okay, thank you.
Good morning, everyone. I'm Denise Molinax. I'm with the California Dairy Research Foundation. I know many of you within our group, and obviously we do research and scientific education program outreach. And part of our work recently has been in support of some of our California regulations, as well as information in this general area.
Okay, thank you.
Me llamo Jean-Pierre Catriella. I come from California as well. I'm work with a organization called Dairy Cares, and work on primarily on regulatory issues for the California dairy industry. I spent a lot of my time focusing on ways to manage manure better, to protect water quality and reduce methane emissions. And in answer to your question, about engagement. I think that's an important question. And I think at least in this, there's a lot of people in this group who are based in California. And from my perspective, there is a lot of engagement between the industry and the government in California discussing these issues. It's not a new issue. You also asked, I think, another important question about whether or not the concept of climate neutrality is understood and is being used a lot right now. And I think, in short, I think it's emerging. You know, there's been a lot of discussion, I think, in the past year or so about introducing this concept versus a net zero carbon concept. So it's beginning to emerge in the public policy discussions, at least in California. However, it hasn't really, I wouldn't say it's cemented into the discussion yet, and it's certainly not reflected in the regulations yet. The California legislation for methane reduction is not based on that concept. It's based on an absolute reduction in methane against a 2013 baseline. So that's all I'll add right now, but just wanted to introduce myself. Thank you.
Yep, thank you.
Well, I guess I'll go next, and I'll second what was just said about the climate neutrality not being totally mainstream yet. That's been my experience as well. I'm Kelly Rossett. I am a scientist in the Center for Sustainability Science at the Nature Conservancy, and I provide a lot of technical and scientific support to the Nature Conservancy's collaborations with the private sector and policymakers.
Thank you.
I'll introduce myself real fast. My name is Joe Proudman. I'm the Associate Director for Communications here in the Clear Center. I want to thank you all for joining us. And I think the only person we have left to introduce themselves is Justin. So I'll pass it on to him.
Great, thank you very much. This is Justin Oldfield with the California Cattle Council. We're a statewide marketing order representing beef and dairy producers, and it's a pleasure to be here. Thank you.
Okay, thank you. So well, this is this is the example that there is engagement, because there are different. At least I can see people from the industry, I can see researchers, I can see policymakers. So it's a good example of at least there is gathering of the people. It's I mean, just trying to open with the very general questions. I mean, is there something that what do you think maybe the main opportunities are for moving faster some of these mitigations that we have already been listening to in well, like the facilitators have already been mentioned. I'm aware that in California, I think for manure management, there has been there is some plan that is already in place that is associated possibly partly with the biogas production, and possibly as well with some changes with the manure management. But what is your opinion in general about this? Is there how could we reactivate, move it faster? What keys do we need to use, or levers to?
Well, I don't want to monopolize the conversation, but I think that it's been fairly clear in the public discussion about how we move biogas production and along is through continued investment in that process. We've had a lot of success in building anaerobic digesters and creating renewable energy in California from dairy biogas, at least, which I think, you know, it's very clear in the conversation that there's a lot more cattle than dairy in the world. And there's also a lot of non-dairy cattle in California. But where animals are housed, you know, at a centralized location, it's been we've had a lot of success in building anaerobic digesters, particularly on larger facilities. What's stopping us from going forward is continued investment into that process, or slowing us down. So, and I think the government recognized that in their recent report from the California Air Resources Board, and the industry recognizes that. So it's a simple matter of how much investment do we want to make as a society in promoting these systems. I think there's another major opportunity in terms of manure management. There has been quite a bit of progress in alternative manure management systems, but there's much more that can be done. I was happy to hear the discussion in the panels. I think a couple of panelists discussed the opportunities around nutrient recycling. I think that's something that we perhaps don't discuss enough. But I believe there's a real opportunity there for plant and animal agriculture to work together to recycle nutrients. And California is a particularly opportunistic setting for that, because we have something like 400 crops grown in the state, lots of opportunities and different types of crops that could potentially use manure. Traditionally, manure has been used mostly on forage crops as a soil amendment, but I think if we begin developing manure as a feedstock for innovative soil amendment products, that there's some real opportunities to both reduce greenhouse gas footprints in both plant and animal agriculture, but also to reduce our dependence on, say, mining nutrients and using energy to extract nutrients from the atmosphere. So there's a lot of I see a lot of opportunity to go forward in those areas.
And in that sense, I remember from I think from Jason's presentation that there may be some limitations sometimes, some constraints from the policy perspective, because we are cross-cutting policies that have to do with waste. So at least in Europe, we have a lot of problems with that. So how we define this digestate, for example. So I was wondering whether this is something that could also be improved, because there are some of these strategies that cross-cut different policy areas. So we're talking about waste, we're talking about energy, talking about climate, we're talking about agriculture, and I don't know how well this generally works out for you, but what's your understanding?
I think I mentioned that one of the immediate kind of impediments to this is some language that would define substrate nutrients as being inorganic in origin, so they couldn't be sold to organic farmers or other organic producers in the US, or to many golf courses that are trying to become organic, etc. And so that would have a huge impact on that market, because that's where a lot of the profits are coming from. And it seems a kind of interesting sleight of hand, given that many of the other inputs that organic producers can use are not organic either in a strict organic sense. So I think that it would make sense to try to get some publicity around that issue. But I think another bigger issue that is that these biogas digesters there's a lot of variability state by state in terms of the price they can sell energy into the grid. And so that would be one thing to try to tackle, but that itself is going to be very hard, because this is a whole kind of states' right issue. But I think the bigger issue is to start getting the co-ops and producer groups to start aggregating the carbon credits they have for renewable energy and start selling those carbon credits to Starbucks and McDonald's and other companies, even Walmart, that buy a lot of milk. They should also find this way to make dairy producers more resilient, because they're going to buy that renewable energy anyway. They've all made targets about that. So if we could find ways to bundle that together to make that easier from the point of view of government, or even making it so that co-op milk dairy co-ops could actually sell renewable energy as a power producer onto the grid. We've seen Google and other large companies declare themselves as not declare themselves, apply and get approved as energy producers in every state in the country because they want to have the ability to sell onto the grid excess energy from renewable plants that they're investing in. But I think we need to start thinking about, in particular, dairy farmers and how this might work to their advantage as well.
Because that's been one of the issues, is not being able to reverse meter, right?
Yeah. Well, they paid the same as if you have two solar panels on your roof. I mean, it's crazy. Yeah. These are producing a megawatt or more in many cases per year, so it's not insignificant.
Yeah, so and that's a policy barrier that
right.
Yeah. So thinking about like the other barriers that are there from policy, it's things like allowing reverse metering, figuring out how to allocate public money to things that are the most effective way to accomplish our public goals. One thing related to manure management, I mean, we many years ago just struggling with trying to help quantify the nutrient content of manure so that people could manage that onto their cropland better and thus be able to reduce total amount of fertilizer they were having to purchase to then also continue to grow the forage crops. And I think some of those laboratory issues with quality, consistency, and all that haven't completely been sorted out, so that people may not have enough trust in their capacity to be able to really know how much nutrients are going on, and so then you always have to add extra. And so I don't know how much the irrigated land program in California has helped that, but those sorts of things need to come along with good training and capacity building and all that, so that you can make use of the nutrients that are at hand, and so that that we can reduce the total imports and have better nitrogen balances and reduce the likelihood of nitrous oxide emissions. So when we have these extreme nitrogen balances, extreme surpluses, the N2O emissions just get to be pretty astronomical.
And the problem with applying manure is that it's very hit or miss. You simply don't know what nutrients are in it. But then ask yourself the question, would we ever see the government prohibiting the application of raw manure? Because once you run through a biogas digester and can capture the substrates, you can separate out liquid ammonia, NP and K. You can apply it exactly in the quantities that are necessary. It's just a much more rigorous way and much more efficient way of doing it. But I'm sure there would be a huge outcry about that.
Well, I mean, you don't have to imagine the government prohibiting application of raw manure. They're already doing it.
In some maybe.
In almost every crop in California, only forage crops are really allowed to have raw manure applied. And I don't mean distinguish here raw manure being manure that hasn't been fully composted and heat treated to kill pathogens. So there are laws in California that prohibit application of manure that might contain pathogens to crops that are intended to be grown for human food supply and will not be heat treated in the process. So that's a large majority of crops. But I think the more important issue you raise is exactly what you said about the digesters. I think we need to start thinking of manure not as the finished product any more than milk is often the finished product that a dairy produces. It is the beginning often of it's an input into any number of food products, ingredients, that sort of thing. It's an ingredient. Manure could be an ingredient as well. It could be an ingredient in fertilizer products. And that would tackle a lot of the issues that were raised about, it's unpredictable or whatever. Well, if it were processed to have a predictable mix of nutrients, and even a variable mix of nutrients. Not every crop needs the same nutrient mix. You know, and we see this already. This is not, you know, we see this already happening in some parts of the US and also in countries like Mexico and elsewhere, where they're taking manures and processing them into different types of fertilizer mixes that can be used safely in commercial agriculture for food crops. So I think that's one of the big untapped opportunities here. It's going to require a lot of research and development and incentivization when we have, you know, the research and development done. I know it's something Denise over at California Dairy Research Foundation has already invested in several projects to kind of move that forward, but it has the dual opportunity of improving nitrogen balances on dairies by encouraging export of excess manure. It also could lead to reduction in methane if that manure is diverted prior to anaerobic storage on a dairy. Even without a digester, it could improve it. But as you mentioned, and I think this is important, digestion itself does do things to manure, such as increase the ratio of inorganic nitrogen to that's available to organic nitrogen, and that could sort of be a pre-processing step, if you would, prior to separation of ingredients and stripping of ammonia and different things into ingredients. So anyway, I think it's a fascinating discussion, and there's a lot of opportunity there.
Okay, so from the perspective of more extensive farming, which I mean, it's been nice to see that from Sarah and from Karen, they have highlighted that we always see the picture of the emissions coming from the feedlots, but actually, as for methane, most of them come from extensive systems from the cattle, the breeding cattle. So in this sense, is there anything already in place? Any strategy that comes from the policy perspective? Is there any focus on improving pastures, or I don't know, focusing on regenerative grazing, so soil organic carbon can be explored like as a sink? Is there any of this happening in the US, in California, or?
I don't think so. I think it would be really interesting to see more information that would be able to, or like more data that would be able to compare the enteric emissions from, say, a well-managed pasture that's high quality forage versus where the animals have to walk around a lot to try to eat whatever kind of shrubs they can find and stuff. And yet there are other benefits to grazing in those systems, right? And so you can't just say you shouldn't be grazing this lower quality forage, but what are the trade-offs and synergies in all of the different environmental outcomes? But are there ways that we can manage forage quality better in order to reduce enteric emissions by a certain amount? There's also the cow-calf herd tends to be in feeding situations, at least in the winter, in a lot of places in the country. And so what opportunities might there be to provide feed supplements along with hay and other feed that are provided to the animals when they are not grazing, which especially in some of the northern places, it can be up to half of the year in some places where there's not enough grazing land or enough grazing time available, right? So that supplemental feeding hasn't been explored a whole lot for the extensive grazing animals. And then the work that Karen mentioned on the early life programming, on the feeding 3-NOP or other type things that you can do, maybe vaccines for calves, something that would affect their digestion over a long part of their lifespan might also prove to have some benefits. So those kinds of explorations, I think, are worth trying to put a bit more energy into.
Do you know if there's anybody that's actually working on the application of these types of substances? I was thinking more of the red seaweed type of thing, or others where you could incorporate it into, you know, mineral licks or other things in pasture, because that's another way to kind of have a continuous supply available. It's not a huge amount that's necessary, but 1% is still a lot, and so you have to figure out how to address that. But
yeah, and you hear people kind of mention it as a possibility, but I haven't seen any research on it yet. I'd love to hear it if anybody has been looking at that, because yeah, we have mineral licks, we have watering holes, we have, you know, are there opportunities to provide materials of some sort that, even if it's once every 2 days, what difference does that make, and all that? Right now, where you have to have it every 6 hours or 4 hours or something.
And maybe if you're thinking about it, you could simply either dissolve it or leave it in water and let them drink it. If it was in powder form, it wouldn't be a problem that way. Yeah, it's the other issue that I'm spending more time thinking about is just that we're starting to get a better idea of methane emissions from pasture lands and rangelands themselves, and how important that is and how variable it is. And my question becomes, who is actually monitoring the impact of climate change and increased temperatures on these kinds of emissions, but also on animal health and feed ingredients and availability and the move of animals north following, you know, animal feed grain production, etc. I mean, these are some huge changes that are happening, and nobody is really talking about it, documenting it, thinking about it. It's not really a policy question, but it's a research topic that the land-grant universities used to focus on a lot more, and they're now focusing on things that they get paid to do.
Well, and maybe that's a policy thing in a way. Like if you're using public funds or to fund research, then to make sure that full life cycle or you know, that you're not only looking at one environmental outcome, that we're looking at multiple environmental outcomes at the same time, or at least accounting for them, and say, well, we didn't consider this because we know it's going to be less than 2% impact, or something like that, right? But that has to be part of the research, and it can't just be
right
a little thing at a time.
You know, that you reminded me of another point. So Hans Blank and others have convinced European regulators that they need to have a common LCA methodology. And so by 2024, that will be adopted. And there's a fair amount of focus on that now. But having looked at a lot of LCAs, even for the same things, the results are extremely different. And that's really disappointing because the methodologies are different, the parameters are different, et cetera. So I would hope from a policy point of view that the US and Canada could create a kind of North American bloc to either adopt something similar or go through a similar process. We may have different things we want to weight on this or not, but there's just too much hit or miss going on here in terms of how things are being calculated. And with the best of intentions, it's confusing. With the worst of intentions, it's very convenient.
And maybe it's not just a common methodology, but at least some standardization. Make sure people always record the units and use standard units. Just really simply, right?
That's part of it. Yeah.
Yeah, I think
need a
for me,
common
it's
methodology because sometimes you can't translate from one to another.
But yeah, I think that one thing that would help there is more transparency around the methodologies that are being used here, and especially as it relates to the different metrics. I mean, we've had many discussions about the different metrics that you can use, you know, in creating these climate accounting frameworks. And, it causes a lot of anxiety among a lot of different policymakers and different interest groups, because they don't understand what the differences between these metrics are. And when you start trying to compare between two different studies that have used different metrics, it becomes a mess. And so, I think that rather than dictating, the science behind the method of the science, because we do want to still have room for that to evolve as we learn more, but rather just being transparent about what was done and what metrics were used, what standards were used in doing those studies, so that we can continue to adapt them as we evolve the methodologies as well.
Yeah, I think this has been a little bit of a problem with the LCA analysis and the overuse as well of this type of assessments beyond what it was probably planned to be done for, which is mainly to compare yourself, not to make it to compare it with another one, because that's what now it's it's being done for many, just used as a kind of a marketing tool, which is really neglecting the uncertainties that are behind the assumptions, not just the metrics, it's just the assumptions, the methodology inside. You just change one small factor and that can affect massively your result. So, even Jason mentioned, we are just understanding more and more how imprecise possibly our estimations for methane from enteric fermentation from very extensive systems are. I mean, we are looking at studies in Africa and also already in Europe from extensive systems that are predicting much lower, in some cases, methane emissions from enteric fermentation from free grazing activities. But anyway, coming back to the policy, which is something possibly I was trying to frame, but I wasn't successful, is do you see any potential policy? I mean, in Europe, for example, we have the CA, the Common Agricultural Policy, and it's very focused, or it's intended to be very focused on some payment for ecosystem services. And some of these ecosystem services may be synergistic to some potential climate mitigation, like I was mentioning before, potentially any practices that could enhance soil organic carbon or carbon sequestration from, for example, from agroforestry or other practices. Is there anything like that in the US that could be explored as a synergy? Is a synergistic policy that is not really a policy directly, but it could help some of these more extensive systems that require this type of help?
Yes.
So,
Perhaps, no,
so
go
one,
ahead.
yeah, no, go, you spoke, go ahead.
I was going to say, perhaps I should elaborate. I do think the national dairy industry has worked a little bit in the area of generating phosphorus credits through voluntary measures to within watersheds.
Yeah.
So they've cooperated with regulated entities to voluntarily reduce phosphorus runoff in exchange for credits for that are then purchased by entities that would have had to pay significantly more to further reduce their phosphorus, and so there's economic benefits all around. Basically, the traditional sources of regulated sources of phosphorus pay less. The dairies receive a payment, and the lakes get less phosphorus. So it's all good. That's one example. Obviously, we have many examples in California of different types of methane credits right now. So certainly we're seeing, a lot around policy to reduce methane emissions through incentives like the LCFS credits and net metering and so forth in California. One of the sort of frustrating developments is because California's incentives have been so strong, some of them are open to projects in other states. So we're seeing money, that is generated by California taxpayers ending up in a pot that is benefiting our competitors in other states, and that's a little bit frustrating. It's a difficult policy issue to solve. There's reasons for it. It's not just the state isn't doing that intentionally. It's just there's certain interstate commerce laws and things that get in the way. So anyway, right now we're those are where I see major incentives that are out there right now, and I think I would like to see more development of nutrient crediting, cycling incentives, in the future.
I think that's easier where the nutrient, the body of water receiving the nutrients is more defined. So you see that in the Chesapeake. You see those kind of nutrient trading systems in other places. Where we haven't found a way to make it work is in the Gulf. And those larger bodies are where in some cases it's just as bad. But we need to figure out how to make that work. One of the points that I wanted to make in response to Augustine's question is that the U.S. answered, I would say, to a lot of the CAP and the green box discussions in Europe was really the CRP program, which isn't directly related to dairy or beef except through feed. But there are now grassland CRP programs too. I just saw the sign up is just about expired for the next grassland one. But the biggest, and this was seen as a green box, a US green box mechanism to take land out of production and reduce total production. And it succeeded in taking about 8% of land out of production, but we found that farmers focused more on the better land, and they doubled production on the better land over 40 years. So it didn't really have the impact of reducing total production on the world market, but it did cut soil erosion in half for the entire country by taking 8% of land out. What we didn't do was actually, we not only didn't allow producers to let that 8% of land go back into carbon sequestration, we actually forced them to mow it every year, which was a mistake, and we should learn from that. And that is a policy that I think that we should move forward with, because as we start having new markets for carbon and for other services, I think we'll find that a lot of farmers find it is more profitable not to farm marginal areas, and that they can actually produce other goods and services from them in a way, and it lets them really concentrate on their better lands.
I'd like to point to, I think, what are their extensive crediting and incentive programs in California, at least for digesters, which can be accessed from other states, as I mentioned, where I think there's three other opportunities that are right in front of us. One of them is the idea of developing a nitrogen crediting system. And in California, it's not a surface water issue nearly as much as it is a groundwater issue. We have extensive rural areas that depend on wells for drinking water, and they're impacted by nitrogen. So, protecting these aquifers from nitrogen pollution, I think, is important. And it also would be nice to have an incentive program in place to incentivize reductions in nitrogen. There's extensive regulations in place as well. And so I think a combination of a carrot stick approach could help accelerate improvements in nitrogen management, particularly incentives that ask farmer or help steer farmers towards drawing their nitrogen supply from nitrogen that's already being produced on animal operations in California, and to use it on other crops that are grown in California rather than importing nitrogen from other areas. The other two opportunities I think that are important have to do with methane emissions. Right now, there is, again, extensive incentives for digesters in California. They do need continued funding to remain effective, and there's quite a few, there's still quite a bit of opportunity to build more digesters in California. That said, we heard a lot this morning about enteric emissions. Right now, you know, the gold standard for incentives in California is through compliance offsets. Rather than just voluntary market offsets. They're worth a lot more. And so we're working to develop an offset protocol for compliance offset protocol for enteric emissions in California, so that as these products that we heard about this morning do come on the market, that there will be another potential revenue stream to encourage and incentivize people to actually use those in an economic way. And then finally, there is also a significant amount of reductions that have been made through changes in manure management, but there are not compliance offset protocol driven credits available for those either. And so we're also working on trying to develop a compliance or adjust the current compliance offset protocol that allows such credits to be steered toward digesters to also allow other types of non-digester manure management projects that reduce methane to receive similar credits. So I think that, you know, in summary, there are clearly some incentive programs out there now, but they require more development to be more effective in the future and to allow other practices, especially beyond digesters, to proliferate.
So I thought it was interesting how Jason mentioned this morning that if there were credits sold, you wouldn't be able to then say that your industry itself is climate neutral or carbon neutral, because someone else would be claiming those credits in order to allow them to continue to emit elsewhere. And so that's an interesting question for agriculture in general, is like, do we need all these emission reductions we can provide for ourselves, or can we sell some of them off to other sectors? So, and I thought that was something I hadn't really.
I agree with.
I like the way that you mentioned it, Jason.
Sorry, yes, just to, sorry to interrupt, but I think we are going to be closed in 10 seconds. Yeah. So just to avoid disappointment of saying goodbye.
Welcome back, everybody. Facilitators, please take a few minutes to present your room's discussions. And Michelle, please start.
Hi, thank you. Ours was looking at climate neutrality for beef and dairy sector and how long that would take. I think we ended with a really nice closing that's going to depend on how we choose to assess and measure, and these continue to be critical. And what's really needed is to how to evaluate these trade-offs and how to put boundaries regarding the timing of achieving climate neutrality. We had a laundry list of some very important key considerations on this journey as well. The need to create various systems in place, particularly to incentivize, knowing mitigation also comes at a cost. The importance of proper policy, addressing consumer needs, balancing communication and education, and how to build from the ground up, bringing the the farmers along, getting their input, and the importance of market incentives, looking at grants, credit markets for greenhouse gas reduction. The other important theme that also arose is the importance of balancing research with the time to achieve these goals. So the need for additional research funding on various aspects in this area remains critical, not putting it all on the farmer, but also thinking how we can get beyond industry to fund that and make that a critical, important headline. I think that's kind of my top line, Frank, in terms of kind of key themes from our breakout.
Thank you very much, Michelle. Can we have our next facilitator, please?
I guess that's me, isn't it? Okay, I was in the policy room, so we had had quite a lively discussion on the different aspects regarding policy in the U.S. and the dairy and beef sector. So, I mean, we started, a lot of the information that was presented by our three panelists was already very useful to frame it and to actually give us some of the key aspects to bear in mind. So we were talking, about, not just thinking about the enteric methane, but also other aspects on the whole life cycle analysis of the beef and dairy system. We were talking about the different definitions up front of climate neutrality, how already Sarah was already highlighting in her presentation how CO2 equivalent as CO2 neutral is almost impossible, and that's why as well we are thinking about the other type of CO2 warming equivalents, which is not adding additional warming. And from that point of view, we went to talk about questions about how the engagement is in the terms of policy, the industry and researchers, if that was working at the moment in terms of all the strategies that the sector is trying to set up for climate neutrality. And we had some examples, especially from California, and we were talking quite a lot about the manure incentives in terms of improving the management and setting up digesters and getting some reductions in methane emissions and also having some renewable energy. We went on to complement that vision of the manure management on the link that has to do with nutrient management, and how this is a good example from this kind of program that has to do with the biogas plants, and how we still need to improve the policy in the policy perspective, how we make the best use of this digestate and how we frame it in the best way, so this can be adopted and used as in programs to optimize fertilization and to take into account that we are closing cycles here in terms of NPK. So this was something that we were talking for quite a while. We were talking about other potential policy or incentives that could be coming in the future, and still needed to be further developed in some cases. And so we were obviously thinking about how the strategies to reduce enteric methane, like adoption of additives or other type of strategies should come into place in the policy in the future. And how, for example, other policies that were not specific on climate, and that was, as far as I understood, and forgive me if I don't say it correctly, those that were used for watershed strategies. So those, for example, targeting to reduce erosion, phosphorus, etc. Those would have some synergistic potential effects for potential enhancement of soil carbon. But on that field, we were saying that this could also be further improved, all of these relationships with this type of policies. And well, I think I recap some of the information that we were talking.
Thank you very much, Justin. Much appreciated. Our last facilitator, Emilio Angefeld, please.
Yeah, thank you, Frank. So we discussed mitigation of enteric methane, and we actually started up by reinforcing Karen's point that methane alone is insufficient. It is very, very important, but it's insufficient by itself, and we need to work also on other greenhouse gases. And furthermore, with some of the methane, enteric methane mitigation strategies, we might be affecting other greenhouse gases negatively as well. So that's something that we need a holistic approach, and we need LCAs, life cycle assessments. For example, there was the example that most studies on methane abatement did not look at manure. So that was one point. We also discussed that we need to take into account other positive impacts of livestock production. We need to discuss the importance of circularity. For example, manure methane can generate electricity, and manure can generate fertilizers. As far as manure processing, we discussed that biodigesters, the investment is it's a limitation, although some of them are cheaper and can be could probably be purchased by smaller farms. There's a big challenge with regard to strategies for the abatement of enteric methane, that is extensive grazing, because much of the research, most of the research really has been done in intensive production systems, in most cases without any grazing at all. In extensive grazing, it's difficult to supplement the animals, and really we haven't investigated much on solutions for those systems and they coincide or they overlap to some extent to what happens in developing countries where the stock of animals is increasing. So we have a big problem there, and have to need solutions. Some of them are being investigated, but they are far from offering really strong decreases in enteric methane production. And we also refer to some aspects of more basic research, the importance of understanding the effects of different mitigation approaches on different clades of methanogens, and that can be important because when we're thinking in combining different anti-methanogenic strategies, as Karen explained in her talk, we may find additive effects, but we may also find interactions, in fact, antagonisms or synergisms, and that's going to depend to a large extent on what happens on what methanogens, which groups of methanogens are targeted by each of the interventions. So I think that with that I'm summarizing our discussion. Thank you.
Thank you very much, Emilio. And thanks to all of our facilitators for summarizing those respective breakouts. I also just want to say thank you to our panelists again, the facilitators, and all participants. I truly enjoyed it. And I'm turning it over to Ermias, who will wrap up today's event.
Thank you very much, Frank, and thank you everybody for joining us today. It's been really a wonderful discussion. I was able to join in the different breakout rooms, and I see that everybody's been engaged and participating very well. So look forward to watching the video of all this breakout discussions as well. So the next steps for this is that the discussion will be summarized and it will be submitted to the Food Systems Summit in the next couple of weeks. we hope to get it to you, the summary that is in a few days, and then you can have a look at it, and if you can give us back your edits within about 1 week's time, then we'll be able to include them in the final draft. And the recording of today's dialogue would be available in a few weeks on the UC Davis Clear Center and the World Food Center websites as well. So we'll have multiple opportunities to be able to see. If you missed one breakout room, you can always jump into the next one, and they can see it all on the video that we will share with everybody. So with that, I think thanks again and for spending time here with us today and sharing your knowledge with us. Have a good day and have a good evening.